Okay, it's 7 o'clock, so let's get started. Good morning, everyone, and good afternoon to the folks joining from Europe. My name is Sean Smith. I'm a HPC specialist solution architect at Amazon Web Services, and I'm joined today by Todd and Greg, and my colleague Evan. Just so you know, this meeting is being recorded, so we're going to have some interactive Q&As, and if you ask questions in the chat, we will read those back and answer those. If you unmute yourself and ask them live, you will be in the recording, and we'll share that recording out after. So first of all, let me introduce the presenters. Todd, are you on? Would you like to give your introduction? Okay. Yeah, so Todd Gamlin and Greg are joining us from Lawrence Livermore, and they work on the Spack project. Evan is my colleague at AWS. He's an HPC solution architect. So the other thing that I wanted to make everyone aware of, I sent out an email last night. There is a Slack channel. So if you go to slackpm.herokuapp.com or just scan that QR code, you can join us via Slack, ask your questions there. We'll be moderating that channel for the duration of the tutorial. Great. So diving right in, I guess why do we at AWS think that Spack is really important? And the first reason is that we view infrastructure as code. So through CloudFormation, through parallel cluster, there's lots of ways where you can define a high-performance computing or high-throughput computing infrastructure in code, and then you can reproduce that and repeat it all over the world. And so we see Spack as a critical component to that, and we're going to go through how you can do that yourself today. And Todd and Greg are going to go over what that looks like in Spack. Okay, great. So today we're going to go over how to access the AWS console. I set out a hash link last night. We're also going to go over how to create a Cloud9 instance, so a virtual machine that you can access the CLI. And then we're going to go over usage of Spack and go through the Spack tutorial. Tomorrow we're going to resume again at the same time, also on this Chime meeting invite, and we're going to go over Spack environments, Spack stacks, modules, developer workloads, and scripting Spack. So now I hope everyone got the link to the tutorial that I sent out in the email. We're going to switch over and go to that. And first I'll open the chat up for any questions. Okay.
I'm not seeing any questions in the chat right now.
Excellent. All right, so I'm going to switch over. So you should have gotten a link to this URL. Greg will put it in the chat so that everyone can access it. So the first step here is you're going to check your email for a hash code. If you haven't gotten it, you can email myself or Evan. This will allow you to access the AWS console. We set up accounts for everyone for the duration of this event, so they'll be initialized today, and then they'll be terminated tomorrow after the second session. And they'll give you access to the AWS console. You won't have access to everything, like you can't look at budgets, and they will be shared between two participants, but you'll create your own virtual environment, which you'll have admin access to. So the first thing we're going to do is we're going to go to this dashboard event engine run link. And this, so it'll look a little bit differently for you than it does for me. It'll give you a terms and conditions, and it'll ask you for the hash code. Alternatively, you can just click on or copy and paste in the link that I put in the email, which will take you to a page that looks exactly like this.
Sean, can we take a quick pause? We've got a bunch of questions from people who logged into the wrong Chime instance this morning. So let's try to give people a second to migrate over. I'm trying to let people know in Slack.
Okay.
We have a question from people saying that they've logged in with the hash and it's saying that the event has not started yet.
Okay. I'm just gonna stop screen sharing for just a sec. Okay, so the event is initialized now, so you should be able to see this screen here. It should say event Spack tutorial on AWS, and it should give you the ability to access the AWS console. Great, can you let me know if there's any more questions in the chat?
Doesn't seem to be. Looks like people are just saying thanks.
Awesome. Cool. All right, so today we're going to use US East 1, that's the North Virginia region. That's one of the US AWS regions, and for the sake of these accounts, it's the only one that they have permissions for, so just make sure that you're in that region. So this page, so when we click the Access AWS console, I'm going to go through that again. That's just this link here. It'll bring us to the AWS console homepage. So like I just said, we're in the North Virginia region. That region selection is in the upper right. For the sake of today's tutorial, we're going to use a service called AWS Cloud9. It's a web-based IDE, so it allows you to access a terminal as well as a visual code editor directly from the browser without having to SSH in. So to get there, we're going to search for Cloud9 in services. Another cool option that you have from the AWS console is you can pin Cloud9. So to do that, I'm just going to click on the pin up here, and I'm going to drag Cloud9. I've already dragged it up here, but if I was to do it again, it would look like that. Okay, so now we're brought to the Cloud9 homepage. I'm going to pause here for just a sec. And Greg, let me know if there's any questions in the chat. Anyone who can't connect or is having trouble getting here.
Can you do a quick refresh of what you just went over We have some people who got behind and aren't sure how to catch up.
Sure. All right, so I'll start at the beginning. So in the email I sent out last night, you should have gotten a hash code. That hash code you're just going to copy and paste here. This is dashboard.eventengine.run. And then you're going to click accept terms and log in. From there, we have this AWS console link. We're going to click on that. And then from there, we're going to click on this login link that'll log us into the AWS console. And instructions for all of this are here on this spack-tutorial.workshop.aws link. From the AWS console, you can navigate to any service just by clicking on this services menu and searching for, in this case, I want to go to Cloud9. So if I click on that, it'll take me here. Excellent. I'm going to move forward. So we're going to create a new Cloud9 environment. I'm going to call it Sean-Spack-tutorial. So give it a name that follows this pattern, like your name -Spack-tutorial. Description, we can just call Spack tutorial and go forward to next step. So here it'll give us some options for creating this instance. This is a virtual machine running on the Elastic Compute Cloud, or EC2. We're going to beef up the instance a little bit. So we're going to select m5.large. The first option we're going to leave default as just create a new EC2 instance for the environment. And then platform, we're going to change to Ubuntu 18.04. And this is important. We've created a mirror on S3 with all the binaries precompiled for Ubuntu, which Todd and Greg will go over. So make sure that you select Ubuntu 18.04 here. The rest of the options we're going to leave default. I want to call out this cost saving settings. So what this does is after 30 minutes, it'll actually stop the instance. So the instances are all the instance storage is backed by a service we have called EBS. So the data on the instance is saved and the actual virtual machine is shut down. And then when you go to reconnect, it'll start that instance again. And it just takes like 30 seconds to a minute to do that. All right, so just a recap of that, we're saying create a new EC2 instance for this environment. We've changed our instance type to m5.large, and we've changed our platform to Ubuntu server. Everything else we'll leave as default, and then we'll click next step. This is just a summary of the options that we chose before. I'm going to click create environment. So in the background, this is going and spinning up a EC2 virtual machine, and then bootstrapping the IDE environment that you see here. It'll take just about a minute to connect to this. Greg, do we have any questions in the chat?
We have couple of instances of unable to create a new environment with with a permissions error. Team role / master key is not authorized to perform blah, blah, blah.
Okay, so I think that's happening because you're not in the North Virginia region. So I'm going to go back just a second. So for anyone who's seeing that, go up in the upper right here and click on US East, North Virginia. And then try the create environment again. All these steps are detailed on this tutorial page.
Then we have one person who was in Northern Virginia, but she says that she got the creation failed with the resource rollback requested by user.
Okay. So in that case, if you could just retry the creation, it should work a second time. Okay, so while everyone is creating and waiting to connect to that, I'm going to go over a little bit about Cloud9. So like I said, it's an integrated development environment. So on top here, we have a code editor. It's actually based on Sublime. So if you're familiar with Sublime, you can use like Control-D or Command-D to do multi-select. And then on the bottom here, we have a terminal. This terminal is pre-configured with the AWS CLI. It's also got AWS credentials. So if I was to type AWS S3 LS, it'll list out my buckets. At this time, I don't have any. So yeah, so you don't need to deal with your key pairs to use the CLI. And if you don't use this instance for longer than 30 minutes, because we set the hibernation timeout to be 30 minutes, it'll stop itself and stop charging you for that. Excellent. So I'm going to pause here and just wait for everyone to catch up, and then we'll switch over to Greg and Todd.
I'm pasting the URL also in the chat. So if you missed the Cloud9 setup, there's instructions on the website that we pasted in chat.
Awesome. Thanks, Todd.
It looks like we've got a few people with the same error, unable to access your environment. The environment creation failed with the error. The development environment long hash failed to create. Delete the AWS Cloud9 name tutorial hash stack and try again.
I'm going to defer to the AWS folks for that error.
Yeah, so if you see that error, what you can do is go to the CloudFormation console. So to do that, click on Services and type CloudFormation. And you'll see in the CloudFormation console, there's a stack AWS-Cloud9 and then your name. and you can go ahead and click delete on that. It should be status create failed or rollback complete. And then after that, you can go back to Cloud9 and retry the create.
We're still getting folks who can't create their environments. Do you want to refer them to Slack and maybe help them out individually, Sean?
Yeah, let's do that. So I'm going to hand it over to you, Todd, and then I can log into their accounts and help them out individually.
Yeah. Okay, you want to switch it over to me?
Yeah, sure.
All right, awesome. We're moving. Let me see. Should I be able to share my screen? Let's see. I'm disabled, Sean.
Okay. Let me add you as a presenter.
All right, I'm going to try. Still disabled.
Okay. You should be able to do it now.
Okay. All right, can people see my screen? Probably all of it, right? Great. Okay. Is this coming through okay, Sean?
Yep.
Okay, great. So welcome to the Spack tutorial. Thanks, Sean, for the initial setup. I'm Todd Gamblin, and I'm gonna start with this overview of Spack, and Greg is gonna go into the basics tutorial. If you're still having trouble with the AWS setup, then we've pasted some links in the chat. So I think that probably the best thing to do if you're having connection problems is to go to Slack and to message Sean and Evan individually, or just message in the tutorial channel over there, and they'll help you. And so I think we can probably get people sorted out that way. So, all right. This is our first AWS tutorial. So thanks to AWS for setting this up. All right. So for people who want to follow along, we're going to be following the tutorial scripts at this URL. So if you go to spacktutorial.readthedocs.io, everything we're going to do today is online here. And if you fall behind, or if you can't keep up with us, you can always go through the things that we're doing here on the website. So go to spacktutorial.readthedocs.io. If you want more information on Spack, there are these websites down here. I'm not going to highlight them too much, but the whole tutorial is online here, so you don't have to keep up with what we're doing. All right, So the motivation behind this is that software complexity in HPC is growing. If you look at a typical HPC app, this is NALU, it's a generalized unstructured, massively parallel low Mach flow app. This thing already has some large number of dependencies. Most of them are because it depends on Trilinos here, but this is not even a large application for HPC. If you look at DL2, this is a finite element library, it's even bigger. And if you look at some of the machine learning codes that people try to build on HPC machines like RMiner, this is a data mining library. There are a ton of packages that you have to manage just to get something installed. So this is the main package over here, and everything to the right of that is its dependencies. This is R in the middle, and then these are all of R's native dependencies. If you try to think about a production environment for HPC, so if you're in industry, you might standardize on your deployment platform and say, hey, we're going to deploy on Intel x86 cloud nodes or something like that. There is no particular production environment for HPC. There's a lot of different architectures. There's different places to deploy. People typically build from source in their home directory. Do you want to deploy at Livermore, Lanel, Sandia, some other lab, some other university cluster? Which MPI implementation do you want to deploy on which compiler, which dependencies, which versions of them? There really isn't a single production environment for HPC because we're on the bleeding edge. People use lots and lots of different machines, and reusing other people's software is hard for this reason. Basically, every deployment is a port. And so Spack is designed to help with this problem. If you look at the exascale software stack, at least in the US exascale program, it's actually now something like 24 applications, 80 software packages, 5+ target architectures or platforms that we care about, 7-ish compilers on all those different machines, 10 programming models, and maybe 2 or 3 versions of each package and all the external dependencies. If you were to expand all of that out, it's like 1.2 million combinations. We can't build all of that stuff, but we'd like to have a quick way to pick the components that we want and to build a stack with those. And so, every application has its own stack of dependencies. It may differ by app. Developers, users, and facilities, they spend lots of FTE hours building and porting this stuff. And we often trade reuse and usability for performance. So if you just get the application working, it may not be worth it to go through all the tuning again just to build a version that may not perform better. So we need to make this easier. We need a way to sample this space and to build configurations on demand. People use containers for this a lot. And they're a great way to reproduce and distribute an already built software stack. But somebody needs to build the container, and that's not trivial. If you've seen some of the Docker files that people produce, they get to be very long. They rely on a lot of system dependencies. Maintaining the Docker files from release to release can be a pain. And using the OS package manager inside of a container can be insufficient because you only get one version of everything in the OS package manager. You can install that if you have 2 applications that depend on different versions of things, or if you want to use some kind of workflow, you may have trouble doing that with just the OS package manager. And you need to rebuild the container frequently to support lots of different hosts, not just one. And so that can be a challenge. So containers are good for saving a snapshot, but you need something to help you build the container. So this tutorial is about Spack. I think everyone here knows that, which is a flexible package manager for HPC. It's designed to be simple to install. So all that you have to do to install Spack is clone this URL, source a setup script. We'll do this in the basic section coming up. And then you can go and install a package. And this will install HDF5 and all of its dependencies. It'll download them from the internet, build them, and install all the different pieces. The difference between Spack and typical package managers is that we can do this. We can install HDF5, but we can also install it at specific versions. We can build it with different compilers. We can build it with different MPI implementations and different dependencies, different build options, and so on. And we try to make that easy. So you're going to learn more about that in the basic section. Who's this for? Well, we try to target the whole spectrum of users. So we try to target end users on HPC systems, so people who just want to install and run HPC applications and tools. We try to target HPC application teams, so people who manage a bunch of third-party libraries on their own. We target package developers, so people who just want to get their software out there for other people to use. And then finally, one of the original use cases for Spack was user support teams at HPC centers who deploy lots of software for users. So most big HPC sites will have a team of people doing this, people who have to build and install the software for users, and that can get to be very tedious. And so we want it to be as easy to use software in all of these different environments as it is, in the cloud or on your laptop. So Spack is used worldwide. This is just a map of all the places we've received hits on our documentation site recently. It's got over 4,300 software packages. We get close to 3,000 monthly active users on the doc site, so that's where all these dots are coming from. And over 600 people have contributed to Spack in one way or another. A lot of those people just contributed a new version of some piece of software, but every contribution is valuable, and we've tried to make it easy to contribute to Spack so that we can grow the community. If you look at the documentation site and the number of users, this is sort of our best proxy for how many users we have. This is probably a large underestimate, but we get about 3,000 monthly users, and it's growing over time. So this top line is monthly users over time. And you can see that, 2 years ago, we were at about 1,000. Last year, we were at 2,000, and now we're close to 3,000. So it's growing. Spack's used on many of the top HPC systems, including the top HPC system. The Fugaku open source software stack is deployed entirely with Spack. It's the official deployment tool for the US Exascale computing project, and so we're working to deploy the ECP software stack across all of the national labs machines in the US. It's used in one way or another on at least 5 of the top 10 supercomputers. We have collaborators in other communities that aren't, traditional HPC. So the high energy physics community uses Spack for a lot of their analysis applications for things like the Large Hadron Collider and other big equipment like that. So Fermilab, CERN, and other collaborators have contributed heavily to Spack. They did the binary packaging component that you'll see in action today. It's used on Astra at Sandia and a bunch of other machines. But not just the high end, as you saw. So there are lots of smaller machines using Spack, not just these big ones. It's pretty busy on GitHub. So we merge about 400 pull requests a month. And we have a deep bench of people contributing to Spack. So it's not just a one-person project. It's grown to be pretty large. And you can see that if you look at the contributors over time. And so we released the first version of Spack in 2015, or in 2014 it went open source. In 2015 we presented it at Supercomputing, and you can kind of see that before 2016 or so, Spack was pretty much a Livermore only project. So this blue line here is Livermore. This is contributions into packages. So these are the recipes for packages down here, and these are contributions in the core tool. And after we presented Spack at SC15, it started catching on, and we started getting contributions from more and more organizations. So you can see here that we got a lot of contributions from EPFL, from Massimiliano Coppo, one of our core contributors, and as well as other organizations who started joining in. And then in the package ecosystem, it's even more diverse. We get contributions from lots of different organizations, and Livermore, even though we released the first version of Spack and wrote all the original packages, we wrote about 170 of them. There's over 4,000 now. We're not even writing 10% of the packages. The community sustains the tool. And so we're really grateful to all the contributors for that. Spack 0.15 was released at the end of June, and we just released a point release on this today. We've sort of adopted a regular release cycle where we do 3 or 4 different releases a year, and we backport bug fixes onto the major releases. And so you can look at the feature list here. We're going to look at some of these today, but we have a pretty detailed changelog. You can see how fast the ecosystem is moving and what features are available. We'll go over some of these features at the end, so some of the newer features after you get the hang of the basic usage of Spack and how to write packages and how to just do the tutorial. There's sort of a roadmap section at the end of tomorrow. So hopefully if you stay through there'll be some exciting features for you. All right. This is not the only tool that automates builds. Spack was inspired by these functional package managers. So Nix has been around for a long time. It's got sort of a Haskell-ish syntax, and it was sort of the first package manager that did this hashing of installations thing, where they identify each installation by a hash, and they enable you to store multiple versions of things in the same instance of the package manager. Geeks is kind of a clone of Nix, but written in Scheme instead of the Nix language. There are builds from source package managers. Gentoo's been around for a long time. Homebrew, Linux Brew, and Matports are all popular on Macs. You can think of Spack as kind of a similar system to these, except for instead of managing a single prefix where you're installing into user local for everything, or you're installing into /user, you're installing everything into its own prefix, and you can have as many versions of different packages as you want, as opposed to these systems where you're trying to install one version of each. Spack's main competition in the HPC space is EasyBuild, which is targeted a little bit more at user support teams and sysadmins, people deploying software for users on HPC systems. It makes more heavy use of modules. Spack doesn't require modules, but it can generate them. And it relies on a more fixed software stack. Spack makes it easier to tweak recipes. Easy build is a little more set in stone in terms of what you can deploy and how easy it is to change that. And then the other tool that comes up a lot is Conda. It's a binary-only package manager. You can build Conda packages from source, but it's a separate tool, and it's typically done in a build farm in the cloud. Typically with Conda, you're installing a binary, and you don't always get optimized binaries with Conda. In fact, you usually get unoptimized ones. And so it's hard to use Conda on HPC systems because it's difficult to use the installed software on the machine. And so we'll talk about that in the configuration section today. But generally, Conda doesn't work that well with HPC systems because it's only deploying from binaries. All right, so with that, I'm going to pause. I'm going to take any questions that people have, and I'm going to let Greg get set up to do the basic section. So I guess, Sean, can we switch it over to Greg, and then we'll take questions while he's getting set up.
Yep. So Greg, you can go ahead and take over the screen share. We have a couple questions in the chat.
Okay.
One is, what was that Git URL? If you could go back to that.
Oh, it's in the chat. So GitHub.com, which Git URL, the actual Spack URL. You'll see that in just a second in the basics tutorial, because Greg's going to show how to clone Spack and get started with it.
Great. And then the other question was, what criteria do you use to release version 1.0?
So Greg answered this in the chat, but what we are looking for 1.0 is to have every package in Spack tested in CI so that we do the builds frequently. And we have binaries available for a lot of them. And we are working on a rewrite of what we call the concretizer, which you'll learn about in the core concept section. So what we would like to have is the full concretizer and a tested software stack before we go 1.0. But like I said, we are releasing these what we call major versions. So like 0.14, 0.15, those are our major versions. And if you want to use Spack in sort of a stable production environment, we recommend picking a release, and then we release point updates on those releases for bug fixes. So the releases are pretty stable. And we test a core component of the releases. So we test the E4S stack from ECP, but we have not expanded that to all of the Spack packages. So we'd like to do that before we go 1.0. So we have another question. What if some dependent package is not present in Spack? How will it manage to install that? For example, for a DNN environment, say we need a specific version of CUDA and CUDA because they're tightly coupled. So CUDA is in Spack. We can install that. And you can have packages that depend on specific versions of dependencies. And we don't require packages to be installed by Spack. There are some stub packages in Spack for things that can only be provided by the system. So like for IBM systems, we have Spectrum MPI. We have stub packages for the Intel compilers, or we can actually install those ourselves. You can depend on external software to Spack from within Spack. So you'll see how to do that in the config section today. And so, you talked about containers. Does Spack can Spack help configure and build Docker and Singularity images? Yes. So as of 0.14, there's a Spack containerize command. If you go to the documentation I'll put the URL here, spack.readthedocs.io, and there's a section on containers there. And you can see that basically you can take what we call a Spack environment, which you'll learn about tomorrow, and you can convert any environment into a container recipe. So basically you can say, hey, I want these 3 packages in a container, go containerize it, and Spack will build you a multi-stage Docker build for that. Let's see. CI is continuous integration. Sorry for using the acronym. That just basically means that we test the software repeatedly. So CI basically, on every commit to Spack, we run a bunch of tests and make sure that things build. That's what that means. All right, I think that's all the questions so far. Any other questions before Greg gets started? Okay. I guess we'll turn it over to Greg. Thanks. And I'm going to paste in the chat over here the link to Slack. So you can do Q&A either here in the chat or on Slack. I'll be monitoring both of those channels while Greg is talking, and so I can answer questions there if you have them while he's presenting. All right, take it away, Greg. Greg, are you muted?
My headset was muting me, not the, well, anyway, doesn't matter exactly why. Can everyone hear me now?
Yep.
Okay. So I'm going to talk about basic installation of Spack packages. I'm going to have a couple slides, and then we're going to hop over to the interactive. So, oh goodness. So Spack provides a spec syntax to describe the configuration of a package. Every package in Spack is modeled as a DAG, a directed acyclic graph. And then we need some way to specify from the command line. Todd showed the millions of possible configurations for a given package. Well, we need a way to specify one part of that space. So if you say Spack install MPI leaks, that's an MPI debugging tool from Livermore that we use as an example. If you say Spack install MPI leaks, it's an unconstrained spec. Spack will just go out and build any version of MPI leaks that it wants to. But you might care what version you build with, so you can specify the version with the @ sigil. You can specify the compiler and the compiler version, the % sigil, and then the @ again for the version. You can have build options, plus threads, stack trace equals 4, whatever it is. We also have compiler flags, so another sort of build option. The architecture to build for. And then you can also specify your dependencies. So this is a telescoping syntax. Anything that we could say about MPI leaks, we could also say about the mpitch dependency. Each of these expressions is a spec for a particular configuration. So you build up all of the constraints you care about. Spack will make sure that those are unified properly and fill in anything that you didn't say, and then it will install that for you. Spack list shows what's installed. It's been a very long time since there were only 300, or Spack list shows what's available to install. And it's been a very long time since there were only 303 of those. I think we're at about 4,200 now. Spack find shows you what's actually installed. And you can see here in this snippet, all of these versions coexist. You can have multiple versions, multiple configurations of the same package installed at the same time. We use rpath to ensure that packages automatically find the correct dependencies, and the binaries work regardless of the user's environment. So this is because we think at install time, we know what we wanted. At runtime, we might not remember what we wanted anymore, so we make use of rpath for that. Spack also generates module files. You can use those to manage your software, but you don't have to, and we'll talk more about those tomorrow. That view that we just saw, I'll go back to this, we just saw package names and versions broken down by architecture and compiler, but we can also query for more information, and we can see here we have two seemingly identical call path installations, and it turns out that they're different because of the version of Boost that they were built with. The other thing we'll talk about briefly in the basic installation section is how Spack manages installed compilers. There's a YAML file under the hood, but basically you can ask Spack, hey, what compilers are available? And Spack will search on Linux systems. Spack searches your path variable to find compilers. On Cray systems, it searches module avail. All right, so that's the slides that I've got for right now. Any questions before I go on to the hands-on? Let's see, I'll pull up Slack real quick. And Chime. All right, now, then I'll go on to the live demo and we'll start actually using Spack. All right, so the easiest thing about Spack is installing it. We don't want you to have any sort of problems where you can't install your installer. So it works right out of the box from a git clone. Git clone https://github.com/spack/spack, and we're going to clone it into /spack. Now we're going to have to do a little more to get set up for this tutorial because Spack clones to the develop branch, but for the tutorial we're going to use the latest stable release, and that's version 0.15.3, but we can also use it just from the releases /v0.15 branch. So we'll cd to Spack, git checkout releases v0.15. And generally, when we run this tutorial, one of the most common problems people have is that they did not check out the release branch. If you start seeing a lot of things build from source and take way longer than it's taking for us, that's probably what happened. All right, so let's continue. We need to put Spack in our path. We could just modify our path variable, but Spack also has some nice shell integration for some CD commands, things like that. So we're going to actually source a little setup script. And then we're also going to source a tutorial setup script. Source share/spack/setup tutorial env.sh. And that's going to show a lot of output. What that's doing is getting us onto the same sort of image that we expect. So for this tutorial, we need more space than the default EC2 instance that we all just started up. So we're going to resize that. We're also going to install some basic system software, right? We need a version of the compiler to get started with, a couple versions so that we can see how Spack plays with different versions of the compiler. So that's what we're setting up right now. Once you've done that, you're good to go. You can go play with Spack, install whatever you want. Spack's going to build things from source, though, so most things are going to take a while. If we stay on the path of the tutorial, we have some pre-built binaries that are going to speed things up and allow us to demonstrate a bit more functionality. So we're good to go now. So we can say Spack list, and we see a lot of output fly past, 4,300 packages. We can also list a more restricted view. We can list everything that starts py dash. And in Spack, that's all of the Python packages by our custom. We can also list something more specific. An argument that you give to list is effectively globbed on both sides. You're listing for anything with that string in it. But we're not here to look at what we can install. We're here to install things. So let's start with that. Spack install zlib. And that'll take maybe 15 to 30 seconds. And there we go. And we see Spack installs to this long, complicated path. And that's because we need to be able to have every configuration live independently. But we'll show a lot of useful tools to manage those paths without having to without having to type them out all the time. So we've seen Spack install from source, and that's fine for zlib, but as we go through the rest of the tutorial, like I said before, we need binary packages. So we're going to configure Spack now to use a mirror of binary packages. Spack mirror add, we'll call it the tutorial mirror. And I'm going to just copy and paste the URL here from the script. That's s3://spack tutorial container /mirror. And now we're also going to configure Spack to trust the binaries from that mirror. Spack gpg trust share Spack keys tutorial.pub. So binary packages in Spack are signed with GPG to make sure that no one can feed you malicious code. And what we've done just now is trust the key that I set up when I first started setting up this tutorial. All right, so now things are going to install much faster, and we can really start to explore the spec syntax that we discussed earlier. So here we'll go Spack install zlib, and remember we use the %sign for compilers. So we're going to build zlib with the Clang compiler. We find a binary package for it, and the first time we use a binary package, Spack's going to go out and build patchelf. We use patchelf to relocate the binaries from where they were built before going into the mirror to where we're unpacking them now. So that gets all the paths right, make sure we can find all our dependencies. All right, let's install some more versions of zlib. We can see the available versions, Spack version zlib. We've got a few checksummed versions, and then we've also spidered zlib's website to see what versions we could get. We'll stay with the safe versions for now. Spack install zlib at 1.2.8. And we can also change compiler flags at the same time. So Spack install zlib at 1.2.8, CPP flags equals -03. So we're changing our C preprocessor flags, which are applied to C, C++, and Fortran, building an optimized version of zlib. All right, we've thrown a bunch of installs out there. Let's see what we've done so far. So we can say Spack find. That'll show us all of our installs. We can see that a couple of these look identical in this view. We can also Spack find -lf. -l is long for the hashes, -f for flags. And now we can see what's different about these two otherwise identical installs. I see a question about spaces. All of these sigils that I'm using for the constraints on the spec are space agnostic. So Spack generates a hash for each spec. You see that here in the gray. And this is a hash of the full provenance of the package. Everything that we've talked about so far goes into this hash. And this is Spack's internal designation of what did I just install, everything about it. So as we go into more complicated packages, we'll sometimes refer to this hash to make sure that we install exactly what we mean to. Right, so I'll pause for a second there for questions.
Yeah, can you slow down a little bit, Greg? We're having some people say that we're going too fast.
Yeah, I saw that fly by on the chime notification, so I'm trying to pause for a second and All right. I'm not hearing any questions. Todd, when I go forward, if you see questions popping up multiple times, can you stop me and ask them on the audio so we can cover everyone more quickly?
So we had a question about we had the 03 thing happen again that we saw at Perk, where someone typed 03 and it failed. That one stumped us for a while the first time it happened.
Yep.
So that happened. So the zlib-03 is really an O, not a 0. So there's that. Let's see what else is in here.
It's an O for optimization flags.
There was a question about what optimization do we use by default, and so I said that we leave that to the build system, and that you likely want to pass flags of your own if you want specific optimizations.
We do pass optimization flags to tie it to the architecture. So you see these things are built for x86-64. That's because we publish a container with this tutorial, and so we build it for the lowest common denominator. But if you just hopped on one of these systems, you would be getting things built for Skylake AVX 512. You can see that by running Spack Arch. And so that we'll throw the for GCC it's -march flag, but for whichever compiler to specify the ISA that you're using. All right. I see a question about which compiler people should install. If you go back up in the tutorial, this source command, source share spack setup tutorial env.sh should install all of the compilers that you need.
If you missed the tutorial setup script, you may need to run Spack compiler find again after running it. So I don't know if you want to point people to that, Greg. But at the beginning of this section, Greg ran the setup tutorial env.sh script, which we need on the AWS environment to get the compilers in there. Greg will show it. Yeah, right there.
Yeah, right
so
here.
If you did not run that, you may want to run it again and then run Spack compiler find to get the compilers in your environment.
Yeah, so we can go Spack compilers. That'll show us the available compilers. If you don't have those three, make sure you've run that script and then run Spack compiler find. All right. Looks like we have a bunch of questions and answers going on Chime. I'm going to keep moving. So I'm going to clear to bring this to the top of the screen. So now let's talk about a package with a dependency. So zlib has no dependencies. Now we'll Spack install TCL. If anyone's not familiar with TCL, it's the language that most, well, maybe not anymore most, but module files up until a few years ago were written in. And it's our example because it has exactly one dependency, and that dependency is zlib. We can see in this first example, we install TCL, Spack fills in the defaults. The default configuration of zlib we've already installed, so we don't have to install that now. Spack sees that it's already there. We install TCL and we're ready to go. But we can also specify how we want to install our dependencies. We can say Spack install TCL depends on zlib, the caret sigil for dependencies, zlib at 1.2.8% clang. And this is a configuration of Clang that we did not install earlier. So Spack goes out and builds it, because it's a prerequisite for TCL. And now it's installing TCL again. But what if we want to get really specific about the hash or about the package that we install as a dependency? We can use the hash. So we saw earlier Spack find -lf, and we saw that our optimized zlib down here has a hash h6i53, etc. So we can Spack install TCL depends on that h6i hash. And when we're specifying the hash with a slash sigil, we just need to specify enough to make it unique. Spack will tell you if it's not enough and you can add more. So here we see we're using this zlib that we already had installed, and now we're installing TCL. While that's installing, I saw we had a question about where config.log goes. So we log all of the output of the build process, and that is stored in a hidden .spack directory in the install prefix. Other build artifacts outside of the build output are not necessarily stored, but they will be available in the stage directory where Spack is building it if there's an error. So you can go back and look at config.log, figure out what went wrong, and then you'll still have the build output saved when it's successfully installed. You can also tell it to keep that build stage around if you want to look at config.log. There's a -- keep stage option to install. I also saw a question go by earlier about I just blanked on what the question was, so maybe I'll see it again and answer it later. Okay, now that we've installed some things with dependencies, we can take another look at the Spack find command. So Spack find, the -d flag shows dependency information, and we'll show the flags and hashes again as well. So here we can see each of our tickle installs shows the associated zlib. We can see this most recent one that we did is built against the h6i. And then we can see the other two installations of tickle that we did against the non-optimized zlibs. Oh, I remember what the question was earlier. It was about installing from source, even when the mirror is active. If you install something that's not in the mirror, it will install from source automatically, but you can also specify -- no cache on a Spack install. I don't recommend doing that during the tutorial though, because some of these things will take quite a while. All right, so let's install something a little more complicated. We'll Spack install HDF5. So that'll take a bit longer. It's got, a solid few dependencies. Mostly these are dependencies of OpenMPI. By default, Spack will use OpenMPI to satisfy an MPI dependency. As we go on, we'll show how we can change that. So let's look at questions. Shazeb had a question about the Spack build cache list command. That's a bug that we know about. We'll fix that shortly.
That's actually fixed in develop. It's just not backported to the release branch.
All right, so probably in the next release. All right, and here's
Yeah.
HDF5.
0.15.4.
So HDF5 is also a more complicated package in that it has different build options. You can build serial or parallel, etc. So by default, it builds parallel, HDF5 plus MPI. But let's build serial HDF5. We'll Spack install HDF5 without MPI. So we'll kick that off. Tilde MPI is the same as dash MPI, is the same as MPI equals false. But for Boolean options, we generally use the shorthand tilde or plus to turn it on and off. We also might want to install HDF5 with a different MPI implementation. MPI isn't a package itself, but lots of things depend on MPI, and so we handle it through what we call a virtual dependency. So HDF5 doesn't depend on OpenMPI or MPitch or MVAPitch or anything like that. HDF5 just depends on MPI, and the concretizer, which is the algorithm that Spack uses to pick the defaults, will substitute in one of the MPI implementations. So if we want a different implementation, we can tell Spack that. We can say Spack install HDF5. This time we're going to install with the HL, the high-level interface, also plus MPI, and we'll say to use MPitch this time.
Greg, we have a question in the chat. Is there a way to do a Spack install -s dry run?
I think you're looking for the Spack spec command. So you can do Spack spec -I. Well, let's just first do Spack spec HDF5. That'll show you for that spec, which was in our case completely unconstrained, what is Spack going to do? And then if you add the -I flag, Spack will show you the install status for all of those things, which ones will it need to install newly or which ones are already installed. And you can see in this case, we already installed HDF5 in the default configuration, so they're all installed already.
We have another question. How does Spack generate hashes? Seems to be deterministic. For example, your hashes are the same as mine.
Yes, they are deterministic. So we take the whole directed acyclic graph here, and we convert it to YAML. We can actually see that with the -Y option here. We have a canonical YAML representation of these DAGs, and then we hash the YAML. So the hash of a package is its canonical name in Spack.
And we'll learn how that's generated in the concept section next.
Yep. All right.
We have another
Okay.
question. By default, does it not build a serial version of HDF5?
By default, it builds a parallel version of HDF5.
Yeah, with MPI.
Configuration section, we'll talk about how you can change the defaults, and we just now talked about how you can specify a one-off from the command line. All right, so now that we've installed a bit more stuff, actually, I'll take that question that just came in. Can we specify an existing MPI? If it's something you've already installed in Spack, you can specify it with the /hash syntax that we saw earlier for zlib. And if it's something that exists outside of Spack, we're going to talk about external packages in the configuration section. So that'll be later today. All right, so now we've installed a few things. Spack find -ldf, we can see what we've installed. We can see, if we restrict that to the HDF5s, we can see we have 3 different HDF5s. We have a serial HDF5 and we have parallel HDF5 built with each of mpitch and OpenMPI. You'll notice that this is not a DAG representation. This is a tree. So we lose some of the connectivity here. If you really want to see what's going on, you can graph. We'll give it the spec we just built, HDF5 plus HL plus MPI, depends on mpitch. And you can see a nice ASCII graph with the full connectivity of the DAG. Pretty printed with colors too. All right, so HDF5 is more complicated, but that's still something that most of us could get installed reasonably quickly by hand if we needed to. So now we're going to look at something a little more complicated, Spack install Trilinos. And I pick on Trilinos, but that's because it's useful. Very, very hard to build, but useful enough that people have to build it anyway and use it. So we're going to let that run and install Trilinos, and I'm going to jump back to talk about the find output that we were looking at a second ago. So if you look at this find output, some of these top-level packages you'll see, like M4 here, is not something that we installed explicitly, and it's not even listed as a dependency of any of these things we installed explicitly. And that's because it's a build dependency. So this output only shows the dependencies that are relevant at runtime for OpenMPI, that's hwloc, etc. But you'll see the build dependencies pop up as well because we need those at build time. All right, so as Trilinos is installing still, now we're starting to see what Spack is capable of. Trilinos has 23 top-level dependencies. Most of those have a lot of dependencies of their own. Some of those are full solver libraries in their own right. Installing something like this can take days or weeks for an experienced user. I've heard an estimate that if someone, even an experienced HPC user, is handed Trilinos for the first time, it'll take them about 3 weeks to figure out how to build it. We're doing a binary installation for the tutorial, so the whole thing's going to take about 5 minutes. If you were building it from source using Spack, it would take about 3 hours, depending on your hardware. I think the 3-hour time that I got was on a Broadwell compute node. I saw a couple of questions go by in the chat. Let me see if I can remember how to see the chat while I'm sharing.
Just unminimize it.
Here we go. So,
Greg, if you want, I can just read them out.
that would be great.
It seems like
Okay,
a lot of
so
people are getting hung up on things taking a long time to build. So we posted in Slack the magic incantation for getting the build cache and everything set up, and it's at the beginning of the basic installation tutorial. So if Spack is sitting there grinding on some package like OpenMPI, you probably don't have the build cache set up. So check the beginning of the tutorial and get that going, and it should be way faster.
And we're talking, when we say that, about these commands right here, Spack mirror add and Spack GPG trust.
So we had a question, can we point to an existing MPI as a dependency? Or
We will
PG
talk
as a
about
dependency?
we will talk about pointing to external packages in the configuration section later. Short answer, yes, you can.
Okay, another question. So a lot of people building HDF5 was really slow. I think Todd addressed that. When HDF5 was installed, does it create a module for OpenMPI also, which was installed implicitly?
Yes, it does. We'll talk a lot more about the module generation tomorrow, but every package that Spack installs builds a module. You have the option to turn off building modules for dependencies, but by default, every package has a module built.
Great. Another question, is there a way to list just the specs that were installed and not the dependencies?
Yeah, so if you do Spack find and just take off that -D option that I was using, if you don't use the -D option, you won't see the dependencies. And if you use the -X option for explicit, then you'll only see the things that you explicitly installed. I'm going to just kick off the next build real quick before I answer more questions. So Spack manages consistency across the entire DAG. That means that there's only going to be one implementation of MPI in the DAG, and there's only going to be one configuration of any given package in the DAG. So if we say Spack install Trilinos plus HDF5, depends on HDF5 plus HL plus MPI, depends on MPitch. What we're going to see is that everywhere that MPitch appears, or that MPI appears in this DAG, it's going to be the same configuration of MPitch that was built earlier. So while that goes, I can take some more questions.
Okay. Can we install Spack packages using a cluster scheduler?
You don't use a cluster. Well, you can kick off jobs on the cluster any way you want, but Spack does not coordinate over MPI for distributed builds. If you get multiple nodes running Spack installs, it actually coordinates through the file system. So you can srun Spack install on any number of processes, but it's not really specific to srun. If you just started those builds on the same nodes, you'd get the same result. But yes, you can across multiple nodes, and it will actually parallelize the DAG from the bottom up and spread and load balance across the nodes.
You can do -J 1000.
The -J option controls the on-node parallelism. And then you can also launch it on multiple nodes at once, and it will just silently use every node that it is launched on.
Awesome. And Trevor, there's an example of using AWS Parallel Cluster with Spack, and there we have the Spack root in the shared directory. So the packages are shared out via NFS to all the compute nodes. Another question, can I start installing another package while there is a Spack installation going on?
Yeah, absolutely. It's going to work exactly the same as if you had launched an srun. So you can build a different package at the same time. You can even just launch another process building the same package, and it will just help out and start picking off work from the queue. All right, So now we see Trilinos installed.
Someone asked if we can install ParaView, and I think the answer is yes, you can install ParaView, but you can do that on your own machine because we do not have a build cache for ParaView, and we would be here until tomorrow.
Yeah, so there's nothing to stop you from installing anything in Spack list, but within the time of the tutorial, we probably want to stick to the things that we've prepped for the tutorial just to have the binary packages available.
Yep.
Like I said, it just took about 3 minutes to install Trilinos. It would take about 3 hours if we hadn't prepped binaries. So if we now spack find-d Trilinos, we can see mpitch appears exactly one place in this DAG. We're using the same configuration of it everywhere. We talked about before, this is a very restricted view. We can use the graph command, spack graph Trilinos, to get a better view, but once something's as complicated as Trilinos, it's a little hard to read this ASCII art even with the nice colors. And so we actually got another option to pipe it to GraphViz, spack graph -- dot. You can pipe that to GraphViz. I'm not going to demonstrate that because live demos are Murphy's Law accumulators, and the particular bit of Murphy's Law that we're demonstrating right now is that we did not install GraphViz as part of that setup script. So we don't actually have it on the machines we're using right now.
We could install it using Spack, but we also don't have a binary cache for it.
Yep. All right, any more questions on installing packages before I move on to uninstalling them? I saw someone said, what were those last two commands? Spack find-d Trilinos and spack graph Trilinos. Also, if anyone is wanting to look back at what we ran earlier in the tutorial, spack-tutorial.readthedocs.io, we're in the basic installation section, but the entire script is online and you should be able to go back and look at whatever you want, or if later today you're wondering about something we talked about earlier, you can always ask questions on Slack, but you can also go back and look at the tutorial.
So we have a question in the chat. How would you build a package with debug symbols for the main package, but not its dependencies?
So packages have a plus debug option that turns on debug symbols only for them and not for their dependencies. So if we say spec HDF5, does HDF5 has a debug option? It does. If we say spec HDF5 plus debug, you'll see that turned on debug for HDF5, but it did not turn it on for, well, it turns out none of its dependencies have debug options. So that was a less than perfect example. But let's say for the shared variant, if I build HDF5 without shared, you can see that affects HDF5 at the top here, but that doesn't affect, where did it go? It doesn't affect HWLoc, which is still plus shared. And I can say, depends on
propagate
loc without shared.
Yeah.
If you want everything to be built with debug, you can set a default in your configuration that'll turn on debug for everything, and you can also pass compiler flags, which are passed down to dependencies.
We have another question. How do I list the plus minus tags for a package?
Spack info will give you that list. So I just did spack info HDF5. We'll go over this in more detail later, but one of the sections there is the variants, and it shows the default and the allowed value and what it's doing for every variant. All right, so I'm going to say spack find -d TCL and spack find zlib. And we installed a bunch of these as demonstrations earlier, but no one needs 6 configurations of zlib. So we're going to start
Maybe not no one.
Not quite no one, but at least. So we installed, I forgot a command earlier. We would have installed a version with GCC at 6.5.0, but we didn't. So I'll just skip on to the next one. Spack uninstall spack find -l lf zlib. We can see we have this older version of zlib built with Clang, and we also have the newer version. So let's uninstall the older version. Spack uninstall zlib/pdf. The slash syntax you can use with or without the package name. I think I do it different ways, different times in this tutorial. And Spack's going to tell us, no, we can't uninstall that. There's something that depends on it. There's 3 options for that. 1, you can leave it because something still depends on it. 2, you can uninstall it and all of its dependencies. That's what we're going to do. Or 3, you can force uninstall it and then break things. So we're going to tell it to uninstall all of the dependencies as well. We don't need that TCL either. So now it's saying it's going to uninstall this version of zlib and the version of TCL that depended on it. We'll say, yes, please do. And there we go. We can also say spack uninstall Trilinos. And Spack's going to complain again. Spack's going to say, there's 2 Trilinos. I don't know which one you want to uninstall. You can say uninstall all of them. Or in our case, we're going to just say the specific one. Spack uninstall /J6 is the one we want to get rid of. Yes, we really do. And there it's gone. We can also get a more interesting view of some of the packages that we have installed. The spack find command accepts what we call anonymous specs. Those are any spec that is just a constraint, not a package name. So we can say spack find depends on mpitch, and we'll get the Trilinos that we built with mpitch, the HDF5 that we built with mpitch, and all of the dependencies of Trilinos that also depend on mpitch. If we want just the ones that we can also do that with the CPP flags. I guess I have another example in there. Spack find CPP flags equals -03. You can do this with any constraint. We only have the one thing that we built with optimization flags earlier. We can also look at only the explicitly installed packages. So we can say spack find -x. I think someone asked about this earlier. Here's everything that we installed explicitly. We can look at all the paths for them too. There's a lot of options for the find command. We'll talk about some more of them tomorrow in the scripting section about how you can get machine readable outputs. But I think that's enough on the find command for right now. Maybe I should stop and take some questions again.
Okay, questions from the chat. Does uninstall remove all the build dependencies or just Trilinos from my current environment?
It removes just the thing that you said to uninstall. There is a Spack GC, Spack garbage collect command that will allow you to uninstall orphaned packages that were installed implicitly and are not needed by anything explicit anymore. But by default, it uninstalls just the package that you specified.
Another question, is using CPP flags -03 recommended, or does Spack choose the best flag for each package?
So Spack doesn't choose. Spack delegates to the build system on this. In general, it depends on the package a lot. Some packages have a philosophy that they build a very generic version by default, and you have to specify what you want. And other packages, they know best the best way to build that package. So you really need to know the package that you want to use, right? This is HPC, everything has its own rules. You really need to know the package you want to use, whether that build system builds to a good optimization level on its own. I'd say I probably wouldn't recommend throwing -03 at everything. If you're going to throw a flag at everything, throw 02 because there's a lot of things that don't play nicely with 03.
And then a follow-up question, what about passing the CMake flags?
So Spack controls the flags to CMake, and that's how we handle all these variants, right? We turned on and off the MPI variant in HDF5. That's changing the arguments to the build system under the hood. So we'll talk about that more in the building your own or creating your own packages section later today. Todd will be doing that. But the flags to the build system are very much controlled by the Spack package.
Okay, great. That's all the questions in the Chime chat here.
All right. So let's talk about compilers for a second. So we saw earlier Spack finds all the compilers in your path. I showed this command earlier, but we'll show it again. Spack compilers, there's the 3 compilers we have available, separated out by name and by operating system and architecture. In the configuration section, we'll talk about this more, but for now, let's just go about adding a compiler. So we'll install GCC at 8.3.0. That'll take a second because GCC is another large, complicated package. But the one thing that I want to stress here is that installing a package that happens to be a compiler and configuring Spack to use that compiler are different things. So what we've done right now is we've told Spack to build GCC. But when this is done and we run Spack compilers, we're not going to see a new GCC in there. We've just built the package. So then we're going to also have to tell Spack, okay, this package is a compiler that you can use. We'll do that using the Spack find command, Spack compiler find or Spack compiler add. There's 2 ways we could use that. We could add it to our path and then run Spack compiler add with no arguments, and it would just search everything in our path. That's what it does. The first time you run Spack, it'll do that. Or we can actually give it a path, say, I know I have a compiler here, go find it. And so that's what we'll do in a second. I saw a question go past about the Spack GC command. Yes, the Spack GC command also removes build dependencies. It's designed for building minimal containers, so you want to reduce the size of what you're putting in the container. All right, so now GCC is built. We can say spack find -p GCC to see where it was installed. We can say spack compilers, right? We see it's not added to our compilers yet. Spack compiler add, and we'll take spack location -i GCC at 830. And now we've added that compiler, spack compilers. Now it's ready to use. If we say spack spec HDF5 now there's a newer GCC. So if we installed HDF5 now unconstrained, we'd actually get a new version of it. We can see that using the -i flag here, right? These things aren't installed yet, it's with the new compiler. And we can now remove the compiler again. We'll add and remove this compiler a few times through the tutorial, depending on the section, whether we want it there or not. So for now, we'll remove it again before the next section. All right. I'll take some more questions now, and then we'll move on to, I think Todd will talk about Spack concepts next.
Yeah, you want to do some questions first, Greg, or should we switch over?
I'm not seeing any more questions. Yes, you can make an older compiler default in the configuration tutorial section. Later today, we'll talk about how to do that.
Hey, Greg, I think it's time for our advertised break.
Oh, well then, let's take a break. And I think we're running a little bit behind.
Let's pick back up at 9 Pacific, so in 20 minutes, but let's take a 20-minute break, and then we'll be back on where we were supposed to be.
That's exactly what I was going to suggest.
Yes.
I see a question here about the Intel and Cray compilers. Yes, we support Intel and Cray compilers. We just don't use them in the tutorial because we don't want to deal with licenses for the tutorial.
All right, so we'll be here answering questions and helping people get caught up during the break. So talk to you all again at 9, and if you have questions, then message in Slack or in Chime. I'm going to post the link to the tutorial materials into Slack again as well.
All right, and I'll stop sharing.
I just posted a bunch of links. So the initial setup is there at the Spack tutorial workshop AWS link. So if you have trouble setting up Cloud9 still, that's the place to go. That links to the other places as well, but just for convenience, I linked them. If you want to talk to us on Slack, there is a link there to get an automatic invitation to Spack Slack. So you can ask questions there one-on-one, more easy. It's easier than the Chime channel. And then the scripts for the tutorial that you can follow along with and the slides are available at spacktutorial.readthedocs.io. So check that out.
I see a question about how to set the, oh, Todd already answered it in the chat. But yeah, in the configuration section, we'll talk about how to set defaults for everything.
All right. Are you ready to get started again, Greg?
I'm ready. Now that
All
I
right.
unmuted.
Am I up now? Are we on to the concepts section?
Yes.
Okay. I will share. Let's see. Okay, we did basics. And right. All right, can you see it, Greg? And can you hear me?
Yes, I can see it and I can hear you. Let's wait 1 minute,
Okay.
and it seems like people are just starting to pop back. Yeah.
All right. For folks who didn't see this, Evan put a survey in Slack. So if you want to go over there and respond to this, that would be awesome. If not, that's fine too. And if you put a little caterpillar there for stuck on issues, someone will get to you and help you.
Yep.
Let's see. All right. Let's minimize. And go back to PowerPoint. I can't see the chat or anything, Greg, so let me know when you think people have trickled back in.
It looks like people are coming back. We've got like 30 some odd responses to our poll, so that probably suggests there's quite a few people. Yeah, and
all right.
You know, if half the people responded to the poll, I'd be a little surprised. So
yes.
Means we've probably got 60 people back online. We have a question in the chat. Are there any prerequisites for the next bit? So for the core concepts, this is a PowerPoint section. For the next hands-on bit, there won't be any problem if you haven't run through the entire previous section. You just might see slightly different output when we list what's available or what's installed already, but it won't prevent you from doing the tutorial.
All right, 1 more minute and we'll get started. And again, if you're joining late, go over to Slack and there's a survey up here that you can partake in. All right, let's get started again. Okay, so we started with the basic usage section that Greg went over, and essentially that was to give you a flavor for what does Spack feel like on the command line, what are some typical commands that people run, what does it do. The way that we structure this, we do that, and then we dive back into the core concepts. So the point of this section is to really look at what we were doing in the first section and understand how Spack's working internally, and so that to give you an idea of what's really happening. And so if you were wondering, what are these hashes, what's going on, how does Spack store all these different versions, this is the section for you. So if you think about most existing package management tools, they don't support combinatorial versioning. And so a binary package manager like RPM, Yum, APT, all these system package managers that you're used to using, they're managing a single prefix, or at least a single root of the file system. So RPM installs basically one version of each package to slash. And if you want to have multiple versions of a package, you have to write a bunch of separate package files for those things. So things like OpenHPC do that. They're designed to manage really a single stack. And so all the libraries, for example, are unified into like one lib directory, and everything has to be consistent. And so, that's designed for seamless upgrades to a stable and well-tested stack, one central installation, one version of everything for the most part. Port systems like BSD ports, Portage, Mac ports, Homebrew, Gentoo, and all those, they also manage a single prefix, but they build from source. Although actually Homebrew is mostly a binary package manager these days. They have some support for parameterized builds. Like you can get sort of a one-off version in Homebrew sometimes, or maybe in Gentoo it supports a little bit of multi-versioning, but you generally can't just ask for what you want. And virtual machines and Linux containers let you build anything, but you kind of have to build it yourself. There's no syntax for saying, hey, I want this version of this thing. Spack's designed to let you get any version of anything that you want built with whatever compiler you want. So we allow flexibility, and we try to make it so that whatever configuration of the package you want to install, it can be there and it can coexist with all the others. And so if you think about how this works, say that we have this MPI leaks package that we're using as our running example. MPI leaks, like Greg said, it's a tool that we built at Livermore for debugging MPI programs. It depends on MPI, and it depends on this call path library here. And call path depends on MPI and dyninst, and then dyninst depends on libdwarf and libelf, and libdwarf depends on libelf too. This is what the packages that Spack installs looks like. This is what packages look like in Spack. And if you think about this, this is showing names on the nodes in this graph, but what's really happening in Spack is that each of these nodes has a lot more attributes. So MPI leaks has a version, it has a compiler version, it has a bunch of parameters for all the different ways it was built. Call path also does. Every MPI installation has a bunch of options. All those things that you saw in Spack info, they're parameterized on these nodes. And so every unique configuration of a graph like this in Spack, that's one configuration. And so what we do is we take a canonical representation of this graph and we hash it. And so really what you're seeing here when you see an install like Darwin Mojave Skylake, Clang 10.0.0 Apple, this is where the things actually get installed in Spack. Every single package that you install gets its own prefix, and it's uniquely identified by this hash. And we could just name the directories after the hashes, but we put this other information here so that you could actually see what was installed and sort of navigate it in the file system. But really all we need to identify any Spack package is the hash. To allow all these different things to coexist, we do something, we use RPaths in all the binaries. And so if you think about that here, MPI leaks here will have RPaths for all the libraries in call path and all the things in MPI. And what that means is, if you understand what LD library path is, it's an environment variable that you set that says, here are the directories you should search for libraries that you depend on. LD library path is sort of notoriously problematic because it's a global variable. It applies to everything in your terminal session. And if different applications need different versions of different dependencies, then you can get really hung up on LD library path. And so instead of doing that as a variable in your environment, Spack actually embeds the path to dependencies in the binaries. And so for MPI leaks, for the different executables there, and for the libraries in that package, they all have RPaths that point to the library locations for these other packages. And so essentially what that means is, if you install something with Spack, it knows where to find its dependencies. And so if you run something straight out of the prefix where we installed it, it should work in Spack. There's some exceptions to that. So things like Python that may require environment variables and things to run, you need to load them or load a module or use an environment, which we'll talk about tomorrow. But for binaries and for compiled programs, we add RPaths to everything. And so we make sure that things can run the way that you built them without you having to remember what modules to load or what environment variables to set. So you saw this syntax that we use, the Spack syntax. It allows you to constrain versions of dependencies. And so you have some control over how this graph is built. So if you say Spack install MPI leaks with the Intel compiler at version 12.1, depends on libelf at 0812. One of the things that we guarantee you in Spack is that there's one version of every one of these packages in the graph. And so if you build MPI leaks and say dynast and libdwarf both depend on libelf, we guarantee you that there's only one version of libelf that's linked into your application. You don't get libdwarf loading one version and dynast expecting another version and exploding because it finds the wrong version. And so what that also means is that on the command line, you don't really have to know much about the DAG structure to talk about the dependencies. So you can say Spack install MPI leaks with Intel, and then you can just say libelf. You know that libelf is somewhere in there. You don't have to know all the dependency relationships or anything to build that. You can just say, well, libelf is breaking me. 0813 didn't work, so I'll try 0812. And so that's what this is doing here. It says, libelf, I want that one to be at 0812. The rest of it, I don't care. Build it however you want. But this is the constraint that I want on the build. The other thing that we do in Spack is we handle versioned interfaces like MPI. This is something that's useful for HPC because there are so many ABI incompatible interfaces. And so what that means is, so MPI, you can build an MPI program with any MPI implementation. It's source compatible, so that's API compatible. That's the application programming interface. What's not true of MPI installations is that they're binary compatible. And so the application binary interface, if you compile, say, OpenMPI, an OpenMPI built application or a library is not compatible with something that was built with MPitch. The types are different and they're represented in a different way in the binary. And so we call things like MPI in Spack a virtual dependency. We let the package depend on MPI. And what that means is that we can swap any MPI implementation into the build. So we let you multi-version by dependency. So you can say, if you want to install MPI leaks with a specific version of MPI, you could say Spack install MPI leaks with mbappage at 1.9. Or you could say Spack install MPI leaks with OpenMPI at 1.4 or higher. And so that's what that's saying there. So that depends on OpenMPI. And the package is written in such a way that it just says, I depend on MPI. Spack knows that mbappage and OpenMPI provide MPI, and it knows how to match the MPI versions up. So if you asked for MPI 2 or higher, like down here, if you said Spack install MPI leaks with MPI at version 2, we'll find an implementation that provides MPI 2. This is typically not something you'd write on the command line, but I'm showing it here just to show how the virtual dependencies work. Normally what you would see is that the package would say, I need MPI 2, or I need MPI 3. And then Spack is forced to find an implementation of MPI that provides what the package needs. So if MPI leaks needed MPI 2, it would just say depends on MPI 2 or higher. And then the user can specify any MPI version that provides MPI 2 or higher. Otherwise, Spack will complain. So the core of Spack and the part that fills in all these details for you is called the concretizer. Other package managers call this dependency resolution. We call it concretization because we like this idea of an abstract spec and a concrete resolution. And so what's really happening when you say Spack install MPI leaks depends on call path at 1.0 plus debug, depends on libelf at 0.8.11. This is what you might write on the command line. We take that spec and we normalize it, and we make what we call an abstract spec. And so that's a graph that has some of the constraints on it, but not all of them. And so this is what you get from just this specification. Internally, Spack takes that thing and it concretizes it. And so it generates a spec that has everything filled in. And so what that means is that for every variant on the spec, for every compiler, for every version, there has to be a value. Spack has to fill something in. And so we iterate until we find something that satisfies all the constraints on the DAG. And we fill in all these blanks for architecture, compiler, version, dependency version, and so on. And once that's done, we can install this. And this is an important concept in Spack because what you'll see in the packaging tutorial, this reduces the effort of writing package recipes. If you've ever tried to write a build script that works in lots of different places, one of the most common things you can see there is that the build script will go out and say, hey, is this installed? Is this installed? Is this installed? And they'll look in lots of different places on the file system and so on. And so we found that lots of people were writing scripts like this. In Spack, that's all done for you. So Spack basically says, here's what you get. This is your configuration. And your job in the package recipe is basically to translate this into build instructions. And so you don't have to go search. Spack just fills in the dependencies for you and hands them to you. Once this is done, when we install, we store all of that provenance on disk. And so there's a spec.yaml file for every installed package in Spack. And you can see this information when you type Spack find. So we saw in the basics section earlier that you can say Spack find, you can query by compiler, you can query by option, you can query by flags and so on, and search what's installed. We have all this information and we keep it around. So you know what's installed, you know all this information, you know how something was built. And Spack spec basically shows you the result of concretization. You saw this earlier. If you want to see what Spack would install if you said MPI leaks, this just runs the concretizer. It says, okay, my spec is MPI leaks. It doesn't have any constraints. Here's what I get if I flush out all the dependencies on that. So it's telling you what it would do. All right. So one thing you should know about Spack is that it does build everything in its own compilation environment. And this is, again, to try to make it so that you get exactly what you asked for. And so that we have a reproducible build environment. So I'm not going to get into all of the details here, but suffice it to say that basically every build in Spack gets its own process. And so if you install a package, we're going to install the first package, the second package, and so on. For each of these packages, we're going to fork a separate build process. And in that environment, we clear out things like LD library path. We clear out things that generally interfere with builds so that you get only what's Spack expected to be in the build. The other thing that we do is we use these compiler wrappers. And so, the mechanism for this is a little, complicated, but essentially in the build environment, we set CC, CXX, F77, and so on to point to these Spack CC, Spack C++, and so on executables. These end up calling the real compiler in the build environment. And in between, we're able to insert some flags. So we insert includes, library search paths, and R paths on the link line so that your package gets built with exactly what was in that tag. And so that's how we ensure that all of those packages in that large directory tree know how to find all their dependencies. We basically we force the R paths in there. So, you could think of Spack as a big system for injecting compiler wrappers into builds, and it kind of is. We do more than what's shown here. We actually name the compiler wrappers after the compiler they're supposed to call, so that things like libtool don't get confused. And we do a lot of things to try to make sure that the build works the way you'd expect. A lot of times injecting these flags will make things that were built with auto tools just think that the packages are on the system. So it can be kind of easy. You may not have to provide command line options for all your dependencies. They just appear because they're on the -i's and -l's on your compile line. And we know where they are at runtime because of the R paths. So basically the whole point of this is the build environment in Spack is designed to make it easy to find the dependencies, and we try to make it hard to find the dependencies that you didn't intend to build with, which is important when building really large package graphs. Spack has some support for Python. You may know from installing Python packages that when you build something, or when you install a Python package, it generally wants to live in the interpreter prefix. And that kind of runs up against the way that Spack likes to install things, where everything gets its own prefix. What we do to kind of bridge that gap is we allow Python packages to extend Python. And so instead of saying they depend on Python, you'll see more about this in the packaging tutorial. We can say they extend Python. And if I install one of those, it'll get linked into the interpreter prefix if I activate it. And so there's this Spack activate command that you can use. We're not going to demo this in the tutorial, but basically if you want something like NumPy to be in your Python environment by default, you can activate it, and we'll just symlink it into the interpreter prefix. And then if you run Python, it'll be there by default. The disadvantage of this is that it kind of pollutes your Python install. And so what we're recommending now is to use environments. And so we'll learn more about that tomorrow. If you do everything in an environment, you won't pollute your Python install, and you won't need to use this activation stuff. But we're mentioning it here because this is how a lot of people deploy Python. Great. Spack supports building against externally installed software, and Greg's going to talk a bit more about this in the config section. But if I say MPI leaks built with call path and OpenMPI and libelf like this, Spack will build OpenMPI if you haven't told it about one that lives on your system. And so you'll see in the next section that you can define a file called packages.yaml, or just use this. This provides some configuration. You can say don't build MPI, and you can say my MPI lives here. And so you can basically tell Spack everything it needs to know about your package that's on your system, and it will build against your MPI instead of one that it builds itself. When we build something like that, it's a little dicier in terms of how we ensure compatibility between the package that you want to build with and the thing that you're building in Spack. And so what we end up doing is if you ask for OpenMPI to be an external package, we sort of chop off all the dependencies under OpenMPI, and we assume that you got those right. It's kind of on you to deal with that. And so if you say MPI leaks with OpenMPI and you have configuration like this, we'll chop off all this stuff, and OpenMPI will point at the external OpenMPI that you provided. And Greg will show you how to set that up in the next section. You may have noticed that all the packages that you've installed with Spack so far, they live in the Spack repository. And so when you clone Spack, you get all 4,300 packages that come with it. If you want to install, or if you want to write your own Spack packages that are just site local, or that you can't release for one reason or another, and we do this all the time for things like export controlled codes at the national labs and stuff like that, you can make a Spack package repository of your own. And so there's a Spack repo command. We won't cover this in too much detail in the tutorial, although we will use it in the next section for the packaging example. You can say Spack repo create some path. You can say Spack repo add that path to your configuration, and then if you list the repos, you can see that you have a repository that's added to in addition to the built-in one. So Spack comes with this built-in repository that lives in the Spack prefix. You can add your own repository in the file system outside of that. And what ends up happening is Spack will search your repo for packages first. So if you add your own custom HDF5 package in your repo, we'll build that instead. It can depend on things that are in the built-in repo if you want it to, but we'll use your custom patched version of HDF5. Or if you want to build, some other package that uses a lot of built-in packages, like if you have your special application that needs MPI and other things, you can put that in your own repo. And once you add this repo, it'll show up in Spack list. You can Spack install that package and so on. And it can work just like the built-in Spack packages, but doesn't have to get checked into the main Spack repository. The last thing that I wanted to talk about a little bit, and you've seen some of this already, is mirrors. So Spack allows you to define mirrors, which they can be directories in the file system, they can be on a web server, or they can be in S3 in Amazon. This allows you to host source and binaries for your packages. And so you can host the source tarballs. We actually have recently set up a mirror for all of Spack. So we're putting all the tarballs and patches and things that you need to download to build things from source in that mirror. And so you shouldn't see things like, when SourceForge goes down, Spack stops working because all the downloads fail. We have a redundant mirror now to prevent that. And you've seen the binary mirror that we use for the tutorial where we host binary packages. Those are basically the same thing. It's just a web server or something in the file system that has sources and binaries. And so the way this ends up working is when Spack goes to install something, it needs to find different artifacts like the tarball with the source code, like patches, maybe a binary cache. It'll look in its local cache first. And so actually when Spack downloads things, it saves them on the disk. So you may see that Spack does not download things multiple times. It just will check on the local disk and grab the tarball there if it has it already. It'll check any mirrors that you have registered in the shared file system. And it'll go out to the global Spack mirror by default and try to find packages there. And then if it can't find something there for some reason, it'll go to the original source on the internet. So every Spack package has its sort of canonical source in it, and that's where we can go and download tarball if we just lose all the other versions of it if we don't have a mirror. All right. So I'm going to pause for questions on that stuff. I guess I'll look at the chat and see if there's questions there. And then otherwise, we will continue on to the configuration section. So let's see. Were there any good questions in chat, Greg?
No questions in chat. We had a comment that it looked a lot like Nix in some ways, which I think you mentioned in the earlier intro section. We just got a couple questions right now. What happens to the ACL permissions to installed package? Does it inherit the destination directory's ACL?
You want to answer that, Greg?
Yeah, so you can configure different permissions on a per package basis for using just the Unix directory permissions, and we'll actually cover that very briefly in the configuration section.
Yep.
Does Spack have a built-in method to push local cache to local mirror?
We don't have a good way to do that right now, but the local cache is just a mirror. So actually, if you just copy the directory, it'll work. So that's the best way to do that right now. So var Spack cache is the default local cache that we use. So if you just put that somewhere else on the file system, it is a mirror, and so you can move it either to the file system or to a web server. So like rsync is a valid way of copying that. How do you set up a proxy for downloads? You can set curl environment variables for Spack. So if you need to set up, I think we have a doc section on setting up a proxy, don't we, Greg?
I believe we do. Let me see if actually, well, I'm doing the next session, so maybe you can see if you can track that down while I'm starting.
I'll try to dig that up and I'll put the answer in the chat. How to get information about virtual dependencies. I tried Spack info MPI, but that doesn't work. So to answer that question, you can say Spack providers MPI, and that will give you information about all the packages that provide that virtual dependency. So you can try it with MPI. You can say Spack providers BLOS. You can say Spack providers LAPACK, and you can see all the different packages that that provide that virtual dependency and what version they provide it at. So try that. Let's see. Any other questions in here? I guess I'll go over to Slack and see if anyone asks. Nope, most of the questions are in Chime. So, okay. All right, so on the feels a lot like Nix comment, yeah, Spack was inspired by Nix. What I would say that the main difference between Spack and Nix is that, so Nix assumes that you have an environment. And if you want to modify packages in Nix, you have to go and hack Nix code. So you really have to mess with the recipes. Spack packages are templated, and so like all the stuff that you see in Spack info, they're basically parameterized packages. And so Nix doesn't really do that. You have to write the code for the recipe, modify it, and then rebuild it if you want to make a package. And so Spack makes it easier to sort of build lots and lots of different versions of things. And you'll really see that tomorrow if you come back for the environments and stacks section, where we can make sort of Cartesian products of different specs of packages. So you could build your application with 6 different MPIs and 3 different compilers at different versions. We can just basically blow out a matrix of that and build the whole thing. So you'll see that tomorrow. So yeah, I would say Spack is more templated than Nix, and it has a syntax for installing lots of different versions of things, whereas Nix basically just installs what's in the repo. And yes, it gets a unique hash, but if you want to build something different, you have to hack some code. Any other questions? All right, move on to Greg.
All right, let's see, share screen. All right, so we're going to move on to the configuration section, but real quick, I want to touch on the top of the basic installation section. If you weren't here during basic installation, you'll need to go through cloning Spack, checking out the release branch, setting up for the tutorial, and then you'll need to jump down here to the mirror commands, and you'll need to do that to get caught up. Once you've done that, though, you don't need to run through the rest of the basic section to catch up. All right, so there are 2 things that we promised in the basic installation section that we'd cover later that we're going to cover in this section, and that is finer grained control over the defaults, default compilers, default variants, etc., and how to use external packages. So we'll start off talking about the scopes. Spack has a lot of config scopes. Everything that we're going to do today, we're going to be modifying the user scope. But if you look at if you look at the instances that we're on, you'll notice /etc/ ls etc Spack has some configuration in there. That's how we set up to use x86 64 instead of the most recent processors as the targets for our tutorial. And all of these scopes get combined into one set of configurations inside Spack. So it's highest to lowest priority listed here. I think Todd mentioned before the spack config blame command. We can say spack config blame packages. And right now, everything we have comes from the defaults, except for one line comes from the system scope. Spack configurations are just directories of YAML files. So every configuration file starts with a top-level dictionary. That's the name of that configuration. The one change we've made to YAML is that we also allow a double colon. You can see that here in the script. And that says ignore all the previous scopes for this section. That can come at the top of a section, but you could also put it anywhere else in the YAML hierarchy. And Spack will drop any previous values instead of merging them. So this example here, it says, here's my compiler, and if there were any other lower priority configs with compilers, completely ignore them. So on that note, we'll go and start talking about compiler configuration. So we're going to open the compiler's configuration file. I am going to first export editor equals Emacs, because otherwise you will have to watch me flail around in Vim. And spack config edit compilers. So here we see the compiler config. This is the YAML file that stores what we saw earlier when we ran spack compilers. So if we close this, spack compilers has the same 3 entries. We spack config edit compilers again, we can add a new entry. I'm going to copy and paste. And this is an unfriendly Emacs, but all right, there we go. We've added that configuration bit. So what is this? What have we done? We took the exact same information that was in our Clang compiler. Maybe I'll open it back up again so we can see both. So here we've got our Clang compiler, Clang at 6. There's no Clang Fortran, so that's fine. And the spec was Clang at 6.0.0. And what we've done is we've copied that over. We've changed the spec to add a gfortran suffix. And we've added gfortran to the Fortran compilers for it. So now this compiler will use Clang for C and C++ code, but it will use gfortran for Fortran code. So now we can compile things like OpenMPI that require a Fortran compiler. The spec is effectively the name of the compiler. The part before the @ sigil has to be one of the known compiler names in Spack. Afterwards should be a version number so that we can do comparisons reasonably on it, but can be anything. So we'll keep the version number so that we know that it's 6.0.0 in terms of finding the appropriate flags, but we'll add a little name to it so that we know it's our Fortran version. So let's use our new compiler and make sure it works. So we will Spack install -- no cache. I think we discussed this earlier. We don't want to build from cache. We want to get our own new version. zlib %clang at 6.0.0 -g4tran. So we get a warning saying it doesn't know how to set the microarchitecture for the compiler for a mixed compiler. And then it installs zlib for us. And that's great. Our compiler works, except that zlib's C code, so we didn't really test the Fortran compiler at all. So now we're going to test that it actually works for Fortran code too. But for this one, we're going to have to do it in 2 steps to install the dependencies from the cache and then install the package itself from source using our new compiler. So we're going to Spack install cmake %gcc at 750. That was already installed. And now we're going to say Spack install -- no cache JSON Fortran. So a simple Fortran code. %clang at 600 -g4tran. And we're going to tell it to use that cmake built with GCC at 750 that we just made sure was installed. And if I could spell, this would work. There we go. So there's JSON Fortran. And we can see our new Fortran compiler works. Yay. All right, so what else can we configure in this YAML file? There were a bunch of other fields to look at. I see a question that someone has messed up their compiler configuration. How can they reset it? If you remove the file, it's tilde/.spack/linux/compilers.yaml. If you just remove it and run Spack compiler find, Spack will regenerate it for you. All right, so we're going to config edit compilers. And now let's play with the compiler flags. So we're going to add to the CPP flags. It's kind of cheating. That's applied to C and C++ and Fortran. So we're, instead of having to specify all 3 of them, we'll just add it to the C preprocessor flags, even though that's not exactly what they're designed for. And we'll test this out using Spack spec, so we don't have to wait for things to install anymore. We'll just show how it concretizes. So this compiler flag is going to be used now for everything that uses that compiler. We can say Spack spec JSON Fortran built with Clang at 6.0.0 -g4tran. And we'll see this CPP flag is set for everything in the spec because they're all using that compiler. So there are some things in the compiler configuration we haven't talked about yet. If I open that back up, we'll see we haven't talked about environment, extra RPath, or modules at all yet. So modules is pretty straightforward. Those are modules that need to be loaded every time this compiler is used. This is particularly useful on the Cray systems, since the Cray programming environment compilers are not usable, or the backend compilers are not usable without modules loaded, but also on systems where LD library path is necessary to make the compiler work properly. Somewhat similarly, there's an extra RPaths field. If your compiler is installed in some pathological way that it can't actually find its own compiler libraries, you might need to tell Spack about some other library to RPath into every executable built with that compiler. And we have this capability here in the extra RPaths. Then the environment field allows you to set arbitrary environment variables. In this example in the script, you can see it's used for a license file. But whatever you need, you can set, you can unset, prepend path, append path, etc. So that's our short primer on compiler configuration. Any questions about that before I go on to configuring preferences? Someone asked if I can explain again what -- no cache does. That tells Spack not to use a binary cache for that install, so it has to be built from source. Any other questions?
So the question is, in YAML, what's the difference between braces and curly braces? And so, I mean, the braces are a list, so that implies order. It's the same thing as opening up a new line and doing -- on successive lines. And then the curly braces are a dictionary. That's the only difference.
All right, then I'll go on to configuring package preferences. So if we want to see what the default preferences are for a lot of things in Spack, we can say Spack config -scope defaults, edit packages. And here we can see the default configuration. So we see we prefer the GCC compiler to Intel. When the versions aren't specified, we prefer the newest version. We prefer certain providers for all of the virtual packages in Spack. We saw this with MPI earlier, that we prefer OpenMPI by default. And by default, we make packages world readable and user writable. Someone was asking about that earlier. All right, so with those defaults, we can say spec HDF5. And we saw this earlier, it uses OpenMPI, it uses GCC, it uses the newest one available, and each package defines defaults for all of its variants. So now let's start changing our preferences. Spack config edit packages. And we'll say packages all. And we're going to say, actually, we want a different order for our compiler preferences. And compilers that aren't listed doesn't mean you can't use them. It just means that they are all tied for last place in your preference. So we could actually leave out a bunch of these compilers and everything would work exactly the same. And we can set providers, and we'll say for MPI, let's prefer mpitch now. We'll save that and exit, and now let's spec HDF5 again. And you can see we didn't specify anything on the command line, but instead of GCC, we got our fancy new G4tran enabled Clang. And if we scroll up, I can't scroll anymore on this thing. I must have accidentally set something that locks my screen. Sean and Evan, if you can figure out what I did, that would be great. But in the meantime, I won't scroll up. But if you scroll up, you can see that this used mpitch instead of OpenMPI.
See if it works now, Greg.
No,
yeah,
now it does.
There you
go. Okay. So yeah.
I think I joined your terminal and it went into collaboration mode.
Oh, and it also moved me back several things ago. So if I spec HDF5, now we can see it again, and there's mpitch. Okay. So now let's set a variant preference. So we've changed preferences that came from Spack's default, but we can also change preferences that come from the package itself. So we can say Spack config edit packages. And now for every package, we'll say variants tilde shared. A shared variant is a convention in Spack that if a package has an option to build shared or static, it's controlled by a plus minus shared variant. So we're going to say everything that has an option to build static in this particular method, we're going to build static. And now we can spec HDF5 again. And we can see that all of the things that have a shared variant, it's turned off. It's actually easier to see with the nice highlighting on the output here, but you can also see it in your window as well. So far, we've only changed every package at once. What if we want something special for HDF5? We can do that too. Spack config edit packages. Just instead of all, we'll say HDF5, and we'll say its variants. I need the colon without MPI. So this is going to build, now we've configured Spack to build a serial HDF5 by default. And we can see Spack spec HDF5. We're still building with Clang, but now there's no MPI at all. And in general, all of the things that we're setting for all packages, we can do it for one package. All right. So we've talked about preferences. Now let's talk about external packages. We got this question earlier about using an external MPI. We're going to start with an external zlib, and then we're going to move up to external MPI. I see a question about where this file got created. It's in ~/.spack in your home directory. You can see we have a mirrors.yaml that was created when we added the mirror in the basics section, and the packages.yaml we just created. By default, compilers are put in a /Linux or Darwin if you're on a Mac OS subdirectory, just to keep them separate across the different operating systems. Since I just finished with preferences, let's actually stop for a second. Do people have questions about that? I see a question about the order of packages versus all. No, it doesn't matter. It's going to look for the package itself first, and then if it doesn't find an entry under the package, it's going to look under all.
For what it's worth, YAML doesn't actually preserve the order of keys in dictionaries like that. So if we're using standard YAML, we couldn't do that anyway. So we don't consider it.
Yeah. Another question, how would you specify two variants for a specific package, HDF5 with and without MPI?
To build both versions, you could either say Spack install HDF5 plus MPI, Spack install HDF5 without MPI, right? Spack install HDF5 plus MPI, HDF5 without MPI, and that will install both of them. Or you could hang around tomorrow and stay for the stacks portion of the tutorial where we'll talk about building up combinatorial matrices of packages.
Another question in the chat, does x86 and PowerPC both go into the Linux directory?
Yes.
Well,
For the
if they're on Linux.
Yes.
So on a Mac, x86 goes in the Mac directory, in the Darwin directory. Can I tell Spack to completely ignore all higher scopes and just use the current directory?
So you can't tell Spack to ignore higher scopes, but there's a -C option that allows you to point at a directory, and that puts it at a higher scope than all of the static ones. So you can have a directory that you keep around that you point Spack at, Spack-C path to configs. And if those configs have the double colon in them, then they'll ignore everything else.
Any way to specify config options for different clusters where my home directory is shared?
Not easily. If that's something you're interested in, let's have a chat on Slack out of channel.
Yeah, we're looking at good ways to support that. The other answer that I would give to that question is you can use environments. And so if you have different settings that you want for different clusters, you can make a different environment for each cluster. And so that's definitely possible right now. But stick around for the environment tutorial tomorrow. Let's see. So
Spack
Evan and Robert
have support for post-install integration testing.
Funny you should ask.
It has some, but I'm engaged in a major project at the moment to add more of that. So shortly there will be a lot more of that. And if you're interested in that, again, message me out of channel and we can talk about what that looks like and how we're defining the criteria for it. Two variants of the same package, how to define both in packages.yaml as external dependencies. Let's hold that until we get into external packages in a second. And integrating packages.yaml with CloudFormation. Sean, do you want to take that?
Yeah, sure. So in the second part of this tutorial, we actually have an example of a CloudFormation script that launches a cluster, and it has packages.yaml that works for the cluster. There's a couple of pre-installed like OpenMPI and Intel MPI modules. So I'm going to post a link to that in the chat so you can see what that does if you want to set it up yourself.
All right, so we'll move on to external packages now. So we'll edit our packages file again. And we'll say for zlib, because we ran our tutorial setup script at the beginning, I know we happen to have zlib at 1.2.8 built with GCC at 750, and it's installed in /user. And if we take that and we spec HDF5, we see that actually overrides our preference for the Clang compiler. It says, I know you've got this zlib configured to use externally. Let's grab it. And let's make all the compilers match when we're resolving all the defaults. So we're going to use GCC for everything. But maybe we really wanted our Clang compiler, so we can say %clang. And now we don't use that external zlib that we installed. Spack says, hey, I want to keep the compiler the same to make sure you're ABI compatible. We're going to use Clang for everything if you said you want Clang for HDF5. So this is useful as one mode of using it, but we can also tell it to be a little looser about the compilers and a little pickier about using zlib. So if we want to tell it always use this zlib no matter what else I ask for, we're going to edit again. And we're going to set zlib to be buildable false. So now, when we say spec HDF5 %clang, Spack says, okay, you want HDF5 with Clang, and you want zlib, and the only zlib I'm allowed to use is this external one. I can't build my own, so you get HDF5 with Clang and GCC and zlib with GCC, and Spack, once you go to the effort to make Spack do it that way, Spack will trust you that you know what you're doing in terms of what compilers you mix. So someone asked, how does it know that the built-in zlib was plus optimized plus pick minus shared? And the fact is it doesn't unless you tell it. So we didn't say anything. When Spack looks at this external configuration, everything you don't specify, it's going to assume was exactly what it's looking for. So everything that you know about it, you should definitely add. In this case, we probably should add plus shared, but we don't know about the optimization flags, so we'll just leave it and let it use it for either version.
We have to fill in the variants with something, and because packages that depend on zlib may ask, like, is it optimized, is it pick? They may do something depending on those things, and so we fill in the variables, but this is the whole concretization process. And so if you don't tell us, we'll pick values, even for externals like that.
So now let's do this for MPI, which is really the most important external package generally. You want to use the system MPI that's, fast on your system instead of building your own most of the time, although sometimes you want to use your own. So Spack config edit packages. We're going to do the same thing with mpitch. We're going to say we've got paths for it. We've got an mpitch at 3.3%, GCC at 750. We don't know what the other things are, so we're just going to leave them. And if we find out more about it later, we can fill them in. And we're going to say buildable false. That should work, right? So Spack spec HDF5 plus MPI built with Clang. And no, that doesn't work. Why doesn't that work? Well, we said we prefer mpitch, but we didn't tell Spack it has to build with mpitch. And when Spack sees that it's got an unbuildable mpitch, and the mpitch isn't the same compiler as HDF5, it just says, okay, I'll build OpenMPI instead, right? This is a virtual package. I can use OpenMPI instead of mpitch. And so it built OpenMPI, or said it was going to build OpenMPI for us. So that's not exactly what we want. What we need to do instead is we need to tell it not to build any sort of MPI. Well, we could just say use mpitch as an explicit thing on the command line. We could say Spack spec HDF5 plus MPI depends on Clang built with mpitch, and then it'll use that. But really, we should solve this by telling it not to build the other MPI implementations. So we're going to Spack config edit packages again, and we're going to say MPI is buildable false, all of the implementations, and then we've still got our path for mpitch.
For those of you who've set this up before, it used to be a lot more painful than that, but we recently made it super easy.
While we're at it, let's go back in there. We're talking about parallel HDF5 again, so we're going to take out our preference for serial HDF5. And now we can Spack spec HDF5 built with Clang. And we'll see, just like with zlib, we get the external mpitch built with GCC, and we build our Clang HDF5 against that. So if we've got standard preferences for ourselves as a user or for our team that we're working on, this allows us to get rid of a lot of the verbosity in our Spack install commands and use the external packages on the system so we don't waste our time building a slower MPI than the one that someone's provided for us. We can set that up in our packages.yaml and we'll get the fast one all the time. Any questions on external packages? So someone says, do you need buildable false for mpitch? No, because mpitch provides MPI. So by saying buildable false for MPI, that covers mpitch as well as all of the other ones. All right. If we've already built OpenMPI before adding MPI buildable false, will Spack still ignore it in the future? Yes. All right. So someone asked about installation permissions earlier. You can also add those to this file. We're not going to go through an example on that, but you can say packages all or a specific package, maybe in this case, Converge is a licensed software and you want to restrict it to the people who pay for the license. You can set the permissions to be group readable and give it a group name, or you could set it to be user readable if it was just for yourself. All right, so important warning before we go on with the tutorial. Spack, oh no, not Spack, rm /.spack/packages.yaml. If we leave those constraints in there, we're going to start building things from source instead of from a binary later in the tutorial, so let's make sure to get rid of that. And then this high-level config, we have a couple of examples for, but I'm just going to talk over it instead since we're running a bit behind. So Spack config scope defaults, edit config. So this is the high-level config for Spack. So you can set the install tree, the install path scheme. We don't recommend changing that one. Where your module files go, where your build stage is. We use Tempter because it's generally fast storage and you want your builds to be as fast as possible. Some other options, but what I really want to focus on, there's the dirty flag, which allows you to, well, you can tell Spack not to sanitize the environment before running. This is generally a bad idea, but there are some systems with pathological environment variables that have to be set to be able to build anything. And so you have that option if you have one of those systems. Then the other is this build jobs option. So you can see it's commented out right now. The default in the code is 16. This is the Spack-J option that people were talking about in the chat earlier. The default value is 16, but if you set this to, or the default value is the smaller of 16 and the maximum number of cores on your system. But if you set this to 2, now you'll only ever build with 2 cores. And so you can see in the examples we give here, you can see how the make-j flag picks up the config build jobs. But we're not going to actually go through the example right now because I want to make sure that we have time for Todd to talk about creating your own package files in Spack. So I'll take some questions right now and then we'll move on to writing your own packages. Someone asked why not /dev/shem? Because not every system has it. So that would be a very reasonable thing for you to set in your configuration is to use /dev/shm to build in because it'll be faster.
We could add it first, that it would ignore it if it didn't exist. So yeah. It might be something we could consider. We've had this setting for a long time. There were a lot of questions here. So one of the questions was, if I've already built OpenMPI before adding MPI buildable false, will Spack still ignore it in the future?
The answer is yes.
Yeah. And then how do we tell the difference between an external package and one to be built by Spack? That was asked like 3 times. How do you tell if something is external in Spack spec? Which I thought was a good question. That's something we ought to add. I don't think we have a good way to determine that there, but we can see it in find.
Yeah, so you can see it. Well, so you can see it by using Spack find and using the dash format option, which we will talk about tomorrow. And there are lots of scary things that you can do with that, but this is one thing that you could do with it.
Yep. Let's see. I don't see.
No, that's a pretty there was a question about adding -system as a suffix to the version for external packages like OpenSSL at 1.0.2j-system. Any disadvantage of this approach? The disadvantage is that you can't use that first mode of using externals that I talked about, where you allow Spack to build it, but it just uses the external when it's convenient to. You can't do that with version suffixes, but if you're using buildable false, then that's a very reasonable approach to take.
Yep.
Let's see. I don't see any questions from there. So we had a question about whether the AWS tutorial instance will continue to be available this afternoon. I'm going to pass on that to the AWS folks, but first I will say we also have a tutorial container that has the same general setup and will work with the build caches. So if the AWS instances are not available and you want to go back and look at something from the tutorial, on Docker Hub, there's a container Spack/tutorial that you can use for that.
And the AWS instances will be available, just not after tomorrow's session.
Yeah, so you have the whole day in between. It's also possible to just create a new AWS account and use the free tier T2 micro to do this, because the Cloud9 instance is the same.
And we also had a question about, can you have buildable false on specific versions of a package which are external? No, you cannot. It's at the package level whether it's buildable or not.
All right. Lots of
It's
good
interesting, but I don't know how we would implement it, so it's probably at least a ways off.
We'd have to change the format of packages.yaml so that they're specs at the top level instead of just names.
All right. So I think that's all the questions. So we're running a bit late, but I'll turn it back over to Todd to talk about writing package files.
All right. Try to share. Here, let me see if I can get back to your IDE here. All right. So I think, yep, okay, I can scroll and everything. I am here. Great. All right. So for folks who are following along, we're going to do the package creation section of the tutorial now. And if you're on spacktutorial.readthedocs.io, it's up here under package creation. So this is the section that we're on right now. All right. So the first thing that we're going to do for this section is we're going to add a custom package repo to our Spack instance. And so this is important to do. If you don't do this, some of the commands won't work. This basically just says, hey, MPI leaks is a package in Spack, but we're going to show you how to build MPI leaks, how to write a package for it. And so we're going to add a new repo at the top level that doesn't have a package for MPI leaks so that we can go through the whole creation process. So the first thing you want to do is Spack repo add, and then $spack root /var spack repos/tutorial. And this is just in the Spack repo. We have a special repo there for this tutorial. So now if you do a Spack repo list, we showed earlier, you can see that the tutorial repo is registered. So if you don't see that, run this command. All right. So if you want to create a package in Spack, it's designed to be very simple. All you really need to make a new package in Spack is a URL for a tarball. And so if you look at this command, Spack create URL to tarball, we're going to type that. And I'm going to just type it over here, Spack create, and I'm going to paste my favorite tarball URL in here. Spack analyzes that URL and says, hey, that's a URL for MPI leaks. And it basically generates me some boilerplate for that package. So right here, we can see it generated a class called MPI leaks. It's subclassing AutoTools package. So it actually looked inside the tarball and said, hey, that's an AutoTools package. It's using the AutoTools build system. I will generate an AutoTools package for that. And then it generated a bunch of fix me statements and things that tell you what to fill in for your package. And so it spawns this text editor. You can see that. And what that really is doing is it created this file. So in that new repository that we added under packages/MPI leaks, it made a package.py file. And so all packages in Spack are implemented in these package.py files, and they're pure Python. There's a little bit of class structure around them, but basically you can do anything in your package. And so if you have something that's really hard to build, you can put in some custom Python code to get around, whatever it is that is blocking you. So we're going to edit this some more in a bit. But for now, I'm going to get out of Emacs, and I'm just going to try to install that package. So I'm going to say Spack install MPI leaks. And basically, this is going to use the boilerplate that I just generated. All I did was I said, here's a tarball, give me a package, let's see what happens. And so you can see Spack will say, okay, I found MPI leaks. I'm going to try to run it with autoconf. And it says, oh, I can't do it. I don't know how to do that. So you can see it tried to run autoreconf on the package. It tried to run configure here. And what you're seeing down here is that it says, oh, I can't find adept utils. And that's an error. And what it's doing is it's highlighting the line in the configure output with the error for you and highlighting it in red. And it says, oh, let's look at this build log for details. So if you want to see the whole build log, you can copy that and paste it and see everything that was in the build log. All right. So I'm going to go back and edit the package a little bit. It turns out this is really because we're missing a dependency. We'll find out more about that later. But for now, I'm going to tweak my package a little bit and try to install again. So let's go back, or actually, I'm going to go back to Emacs. If I exit my editor, I can always get back to my package by saying Spack edit package name. And so here's MPI leaks again. It just opens the file for me. All right. So what you can see here is that there's some structure to this file. We need to add some documentation. So it's a Python class, and it says fix me, put a proper description of your package here. And so what you want to do is I'm just going to copy over here. We put what's called a doc string in Python here for the documentation for the package. And so that's just a description. That's just human readable text that says what this thing is. It says fix me, add a proper URL for your package's homepage here. And so it turns out MPI leaks is available here on GitHub. And so let's see. I can add that here. And it already knows the tarball URL because I gave that to it at creation time. So it already has that. You can add a maintainer to the package, and we're working on automation to sort of notify you if anyone submits a pull request that has to do with your package. So it's good to put that there. It says Adam Stewart here, but I'm going to say T Gamblin if I wanted to get notified every time this gets a pull request. This version directive here, this is just saying this is where to get version 1.0. And so Spack is actually smart enough to look at this URL. And so you can see that it says, I'm going to expand this a little bit, MPI leaks 1.0.tar.gz. It can analyze that URL and tell that that's the version 1.0 URL. And so often, if you want to add a new version to a Spack package, it's just as simple as putting a new version in here and adding a new hash. So if you wanted 2.0 to be here, you could just do that. And Spack's smart enough to extrapolate the URL. For some packages, it's not smart enough to do that, and so you can actually add just a URL here. If you wanted a specific URL for a specific version, you can put it here. But we don't need to do that here because the URL is pretty simple. All right, and then here it says add dependencies if required. I'm going to ignore that for now, and then I'm going to ignore this configure arg section for now too. So with all that, I filled in some extra details, and I can say Spack info MPI leaks, and you can see that it really just parses that file to get the info. So there's the description that I asked for. So if I say Spack info, it just grabs the doc string for the description. It shows the home page that I put in the package. It says who the maintainer is on the output. It has the version information here, and then it has some information on dependencies and so on. So that's how you get your package to have nice output for Spack info. Variants will be shown here if you add them, lots of things. All right, so we ran Spack info. Now we really need to add some dependencies to this. And so if I go back here, it says add dependencies if required. I need to say that this thing needs external dependencies. And so this is one of the most powerful parts of Spack. You can say that your package needs another package just by name, and Spack will build that other thing first. So the first thing we're going to say is depends on MPI. And so that says I need MPI to build. So you need to build an MPI implementation before you build MPI leaks. The other package that MPI leaks depends on is adeptutils, which is something that we wrote at Livermore. It's a library. It has some utility functions in it. So that's the second thing. And the third thing is this call path library, which is for walking the stack and for getting debug information out of a program. And so I'm going to add those three things, and now I'm done adding my dependencies. That's all it took. If I wanted to have this thing depend on a particular version of MPI, if I needed MPI 2 or some MPI 2 compliant MPI implementation, I could do something like that and say MPI at 2 or higher, but I don't. MPI leaks is pretty simple. But these are just specs. These are the same specs that you would write on the command line that you can write here in the package, and so that's how you say what it is you depend on. So the package can have constraints too. So now that I've done that, I added these dependencies. I can go back and I can say Spack install MPI leaks again. And so if I do that now, it's gonna do this concretization, and now it says, oh, all this is already installed from the previous sections. I need to get Liberty, I need tar, I need all these other dependencies because you asked for all these packages. So now it's installing all the stuff that I need to get MPI, adeptutils, and call path from here. So you can see now it's installing Boost. It's doing get text, it's doing tar, it's telling you what was already installed here with all these pluses. And so we're just waiting for Spack to extract all these different binaries. And so this is this part here. There's going to be a lot of these. And so my expectation is that now that I've added adeptutils to this, that it won't take very long, or, well, that it'll find its dependency. And so we'll see what happens. So we're waiting for Boost. I guess I can take some questions while we wait for Boost. Let's see. Do we have any good questions, Greg?
How smart is Spack when it comes to math libraries implementing multiple APIs, i.e. MKL implementing BLAS, LIPACK, SCalaPack, and FFTW?
Pretty smart. So if you say that you depend on BLAS, you can swap in MKL for that. MKL is a BLAS provider. MKL actually provides like 4 different virtual dependencies. I think it's BLAS, LAPACK, MPI, and SCalaPack. And so you can use it as a stand-in, or well, Intel Parallel Studio implements all those things. MKL can be used for BLAS and LAPACK and so on. So you can actually combine those things, and you can define a package that depends on BLAS and LAPACK, and you can satisfy that with either, you can use OpenBLAS to satisfy both of them. You can use netlib LAPACK along with another BLAS implementation. You can mix and match those things. And so if you're interested in that, look at the advanced packaging tutorial. There's some material in there on it. And then otherwise, I would grep around in the packages for things that provide LAPACK and BLAS.
Just to clarify, the advanced packaging section of the tutorial is a section that we deprecated for being a little bit dry. but
Yeah.
has some good information on this.
Yeah, so that's here. Advanced topics in packaging, it really gets into the interface that packages in Spack use to handle virtual dependencies. And so essentially you can write a portable package that can be built with any BLOS implementation using that. And the implementations can say, here's where my libraries are, here's where my includes are, and so on. So there's an abstraction layer there for you, and that the advanced topics tutorial covers some of that. Yeah, it's just a little dry, like Greg said. All right. So we did the dependencies, and we tried to build, and we're still getting the same error. And so it's a little confusing now because I said I depend on adept utils, but it says I still don't know where adept utils is. If I type spack find adept utils, I can see that it installed it. It's there. It's just that it's still not finding it. So it turns out that the MPI leaks package is a little stupid. And so we have to go back over here and add the location of adept utils to the configure arguments. And I'll do that later. I'm going to show you how to debug this thing if we didn't know this. So let's try that. If I wanted to debug this build by hand and not by just running spack install, and you can see up here I ran, let's see. I guess I cleared my screen, so it's all gone. But you can see it couldn't find the adept utils installation. If I wanted to jump into a shell and just debug this by hand, I can actually get into the Spack build environment. So right now I'm in my Spack prefix, right? I'm in the place where I installed Spack. If I want to go to the build stage for MPI leaks, I can just say Spack cd MPI leaks now. And this will take me into the expanded tarball for this package that I'm building. And so you can see it's this long path. But this is, and if I look in the directory above this, I've got the tarball that I downloaded for MPI leaks. I've got this Spack source directory where I'm sitting right now. That's the expanded source. And then these are all the build logs that you've seen in previous output. And so if I wanted to run stuff now, I'm in the directory with configure. So I can actually run, I'm going to copy this path here. It's from the output above, but I'll just copy it from here. I can run configure the way that MPI leaks would. Except for right now, I'm not in a shell where I have the Spack environment. So if I do env grep Spack, you can see I'm just in my normal shell. There's Spack root, but if I want to get into Spack's exact build environment, I can go here and say Spack build env MPI leaks bash. And so let's look at that command. It's Spack build env. This is for build environment. This is the spec of the thing I want to jump into the build environment for. If I just said Spack build env MPI leaks, it's like the env command. It would just print out the build environment. And so it dumps all the environment variables that would be set in the build environment. But if I want to run something like bash, I can jump into a shell for the build environment like this. And so now I'm in a bash shell again. If I do env pipe to grep Spack like this, you can see that variables like Spack root, Spack fc, all those compiler variables that we talked about earlier, those are set. This is all the stuff that Spack sets in your build environment to get things built. So now I'm in the environment that it would build it in. And so now that that's done, I can run, so I'm in the build directory for this package. I can run /configure, and I can give it, I can copy the prefix again. And let's go over here, paste that in. And now I'm doing the configure the way that Spack would do it. And it says, oh, I can't, so I get the same error message that I got before. I can't find the adept utils installation. If I wanted to figure out why that was, I could just run configure -- help like I normally would. And you can see here that for this particular package, it has some useful things. So it has with adept utils equals path. Oh, maybe I have to add that. It has with call path equals path. Maybe I have to add that. Maybe this package is too dumb to know that the environment or that the library exists on the system and I have to add these parameters. So that's what I'm going to do. So now I'm going to get out of this shell. And if I do env grep Spack again, you can see I'm back. I don't have all those environment variables set anymore. And now I'm going to go and edit my package one more time. So let's see. So here's my package. Let's see. I'm going to add some arguments here. And so configure args is the method on AutoTools packages that provides Spack with the arguments that it should use for configure. And let me just fix this up here. Get the indentation right. There we go. So what you can see here is that we're making an array. and it has some arguments in it. And the first one is with adeptutils equals 0. This is a format string in Python. And so this 0 thing will be substituted by the arguments to format. And so we're saying with adeptutils equals self.spec subadeptutils.prefix. And so the interesting thing here is that you have this self.spec object. And so if you remember from the core concepts, the spec is that DAG. That is the graph of everything that you're supposed to build. That's the configuration you're building. And you can query it for information about your dependencies. And so this is how Spack packages are templated. If we do spec sub adeptutils like this, we're saying, get me the spec for adeptutils. It's recursive. That's going to give me the node in the graph that refers to my adeptutils dependency. And I can ask it for its prefix. I can ask it what variants are set on it. I can ask it what compiler it was built with, and so on. And so you can use that information in the build for your package. So all this is really doing is it's saying, grab adeptutils from my graph and get its prefix, and let's pass that in. And then down here, you can say with call path equals self.spec sub call path.prefix. You can get include paths, lib paths, other things from those from these objects. It's quite useful. So again, if you're interested in that, look at the advanced packaging tutorial. And there's a little bit at the end of this one. So now that I've done that, I'm going to run Spack install one more time. And this time I'm going to run Spack install -- verbose MPI leaks. I'm going to go a little off script just so I can see what happened there. And so now it's saying all these things are installed. And what you can see here is here's the configure line. So if I run with verbose, it'll show me everything the build is doing. And it keeps jumping. But if I zoom in on this, what you can see is right there, that green part, there's configure. It's saying -- prefix equals, and then you can see that it has the arguments that I specified in the package. So it's passing with adeptutils, and it expands that out to the prefix of adeptutils. It's passing with call path, and it expands that out to the prefix of call path. And so now that all that is done, a lot more output happens, and eventually it successfully installs MPI leaks. So that worked. It was able to build. And let's see. The last thing I'm going to show is how to add variants. And so I'm going to add a really simple option to this package. So I'm going to get out of here, and I'm going to go back to my package here. And again, I can just say Spack edit MPI leaks if I exit my editor. I keep hitting Control-Z and FG, but edit works too. So now I'm in here. Suppose that I want to have some integer option for my package that I set for different configurations. It turns out that MPI leaks has this option called stack start. And what that means is that it's going to omit some frames from the call paths that it reports. So what you'll normally see is that if you use a tool like this, it reports leaks in places where some MPI call allocated a handle and didn't record it, or and didn't release it. And what's often included in those call paths to those call sites is some of the MPI frames that we don't care about. We just want to know the call up to the MPI call, not the stuff below it. And so we can add, an integer option here that says omit this many call frames before you start unwinding. So that's what we're going to do. So this variant is called stack start. If I put it here in my package, it doesn't really matter where it goes. This is another directive. And so now I have this thing called stack start. It can take integer values. So I just say the value is anything that can be constructed with an int in Python. The default is 0. And I'm going to specify the number of stack frames to truncate. And to support that, once I add that option, I can query it on my spec. And so down here under configure args, I can add a little bit of code to grab that from the graph and to put it on the command line when I run configure in my build. So now I have something that looks like this. And what you see here is I say stack start equals int self.spec.variance of stack start.value. This is grabbing the stack start value out of there. I don't actually think we need the int here. I'll leave it in just in case, but I think this is actually redundant. It'll come out as an int because I specified it as an int up there. And then it says if the stack start is set, then add these arguments to configure. And so you can see we just set the stack start to the same thing for C and Fortran when we set this. So what this enables me to do is now if I say Spack info MPI leaks, you can see that now there's this option. It has allowed values that are integers. And I guess we do something weird with the doc string there. That's new. And then it just says I can specify the number of stack frames to truncate. So now I can install MPI leaks in a slightly different way. I can provide this on the command line. I can say stack install MPI leaks stack start equals 4 to build a version that'll omit 4 call frames. And I'm going to add -- verbose here again, -v for short. And what you can see is it says all that stuff is installed. And now you can see that it added the stack start C and stack start Fortran options to the configure line as well. So there's that. And if we let this thing build, it's going to go on to the end. We'll scroll down here. And we will get an install that has the stack start variant set. And so as Greg showed earlier, when you set a variant like this, you can actually query for it. So if I do Spack find now, or let's say Spack find MPI leaks, you can see I have 2 MPI leaks installations. And if I want to differentiate between them, I can say Spack find -v to show variants. And you can see that this one is just a plain old MPI leaks, and this one has stack start equals 4. And they have different hashes because they have that different variant. So this one has this hash, and this one has this 6i_OKQ hash. And you can actually query for that on the command line. You can query for a version that has stack start equal 4 like that, and it'll just return that one, and so on. So that's sort of a flavor of how to create packages with Spack. It's very easy to add new template parameters and new optional dependencies and all sorts of things. I'm going to go through this last section of the tutorial, but you can read through this. That spec object that we queried in the build, or in the package, there's a lot of things you can do with it. So you can ask things like, am I building myself at version 1.1 or greater? So if I want to do something conditional for a particular configuration of the package, I can ask that of the spec. Am I supposed to build version 1.1? Well, okay, I'm going to do this special thing for 1.1. Am I building with OpenMPI? And so if I have to do something special when I build with OpenMPI as my MPI implementation, I can just say if self.spec sub_MPI.name equals OpenMPI, do something special for that. I can check my compiler. So again, with this satisfies thing, you can use the spec syntax as a query on your graph. And am I building with debug? So if debug in self.spec, I can query whether I satisfy plus debug. This is shorthand for satisfies. And then I can ask, does my dependency satisfy a particular version? And so I can say, if I'm building with Dynast version 8.0 or higher, do something special for that. So if you have a package that changed something when when a dependency got upgraded, you can have conditional stuff for that as well. So it's pretty easy to write terse code that deals with a lot of different options in your Spack packages. All right, so the last thing before we're pretty much done with the package tutorial, but just to clear out this extra repo that we added, you need to run these commands down here. And so you need to run Spack uninstall -ay MPI leaks. And so that says uninstall all of the MPI leaks and say yes to all the questions. So we don't have to repeat ourselves. So now if I do Spack find MPI leaks, you'll see it's gone. And we're going to remove that tutorial repository like this. So we're going to remove the tutorial. So if I do Spack repo list now, you can see I only have the built-in repo. And then finally, we're going to do this rm-rf, that package, just to get rid of the package file that we made. And so now we're back to normal. All right, so I'm going to stop for questions. We're a little bit over time, but I can stay and take questions if people have them. And thanks for attending today. So let's see. I guess I'll bring up Chime and see if I can reduce this. All right. Any interesting questions over here? There's a lot. Wow.
Yeah, we've had a few questions. I've been answering a bunch of them. Some questions about fetching from Git. We have the ability to fetch from Git instead of a URL. We can fetch from SVN or Mercurial as well.
Yeah, if you want to see that, so probably the best resource, and I guess we should probably put this in the tutorial if it's not there already. If you go to spack.readthedocs.io, the packaging guide has all this information. And so this is all the different sections of the packaging guide that can tell you all the things that you can put in your package. And so for things like fetching from version control systems, see fetching from code repositories here. It tells you how to put, a Git repo in your package, how to specify branches, and so on. So all that stuff is there. We support Git, Mercurial Subversion, even Go fetching. So there's a lot of stuff there.
I would say the other best resource for packaging is there are 4,200 packages already in Spack.
Yes.
And quite often, the exact really strange, tricky thing that is close to unique is not quite unique, and there's one that's already had to do that.
Yeah, so like if you wanted to look at your Spack installation, go to var Spack repos built-in, and if you want to figure out, who's dealt with BLAS in their package before, you can do a git grep BLAS here. Oops, let's see, did that work? Nope. Git grep BLAS. So I'm going to grep for BLAS in all the packages in here. And you can see that you can find all the different packages that have something to do with BLAS. So often you can just grep through these packages and find, an incantation like Greg was saying for what you want. And if you don't know, a lot of you have joined our Slack instance. And so, if you haven't, please do. But there's like 700 plus people on there now. And if you ask questions in our Slack, we will answer them. And so often that's the quickest way to figure out how to do something. Other questions?
Someone asked how to remove a package. You just remove the directory containing it from the repo.
Yep.
Let's see. We had a question about how to publicize your package once you've made it. Make a PR to the Spack repo on GitHub. That's where the kind of shared repository of all this build knowledge is.
Yep. I believe Axel has some kind of Spack badge that you can put on your GitHub repository too, but I can't find it right now. Anything else? Let's see, what other questions? Yeah, we always like PRs. Probably the best way to make your package available to everyone is to submit a PR to Spack mainline, because then anyone can install it. Some people, for understandable reasons, keep their packages outside, but the advantage of submitting it to the mainline is that as Spack changes, we will change your package and make sure that it remains compatible. Sometimes we do things that affect a lot of packages, or we make improvements to all the packages, and so we'll keep messing with your package if you put it in the mainline. Whereas if you don't, then you may fall behind the latest version of Spack.
I would also say if you're most of the way through writing a package and you're having trouble with it, sometimes the best way to get help on it is just put up what you've got as a PR. And then people who are interested in that package will see that and will be the most likely people to know how to help you with building it as well. You can also obviously ask the mailing list, ask about it on Slack. These are all great ways. But putting up a PR as the first step is often the most effective.
Yeah, this is Cunningham's law. The best way to get the right answer is to put the wrong answer on the internet. If you put a PR up on Spack, someone will comment on it. All right. Any other questions? If not, we'll be in Slack for the rest of the day. Feel free to ask questions. The Cloud9 instances are available until the end of the tutorial tomorrow, so you can play around there. And if you have questions, if you're doing parts of the tutorial that you didn't get to during the session today, we can help out on Slack. So thanks, everyone. And yeah, we hope to see all of you back tomorrow, because tomorrow we're going to do environments, stacks, we're going to do module file generation, and some developer features in Spack. So basically how to do development with Spack packages. And there's some roadmap stuff at the end where we'll talk about recent Spack features and stuff that's coming down the pipe. So hope to see you all back tomorrow.
Thanks, everyone. I posted a brief survey. If you wouldn't mind taking that, it's in the Slack channel. I'll also post the link here, and we'll see you on the same Chime link tomorrow at 7 a.m. Pacific.
Yep. Tomorrow's way more fun than today, so definitely come back. Yeah. All right, thanks.